All right, so I think I see most faces that I expected to be here. So I would slowly start, and I think everyone else can join in on the go. Let me quickly share my screen. Does this work? Does everyone see the slides? Perfect. Get a thumbs up. Then, yeah, a warm welcome to our first workshop on prototyping cross-reality systems at ISMAR 2022. The workshop will happen online, as you might have figured already. I welcome everyone on behalf of my co-authors, which is a quite long list, as you can already also see by all the logos appearing on top of the page. I give you like a brief overview. Not every one of the organizers is joining today, or like not joining the entire time, but will also come in like later. For example, Michael is like joining a moment later. But yeah, I kind of quickly say hi for everyone, I guess. Also the ones that are a few here can maybe like say hi themselves. So I would start. My name is Uwe Grünefeld. I'm a postdoc researcher at the University of Duisburg-Essen in Germany. I focus in my research mainly on augmented and virtual reality and do kind of all types of topics that touch upon this, from usable security to haptics to visualization to cross-reality systems. I think that's why we're here. And with that, I would hand over to Jonas to say a few words.
Yeah. Hi, I'm Jonas. I'm a PhD student in the same group as Uwe. Yeah, I mainly focus on virtual reality, but lately also together with Uwe on cross-reality systems. I researched haptic through drones using virtual reality, integrated brain-computer interfaces, and also did some research on locomotion in virtual reality. So I think that sums it up very briefly and accurately. Thank you.
Yeah, thank you very much. Then the next one would be Florian, but Florian can't be here today. Florian is did his PhD or is doing his PhD at the University of Glasgow and University of Edinburgh with, for example, Mohammed Kamis is one of the supervisors, but he will say something in a moment as well. And as I heard, he's one of the people where the affiliation soon will change because he is working with Meta Reality Labs. Yeah, maybe the next one would be Mohammed.
Yeah, thanks, Uwe. Hi, everyone. My name is Mohammed. I'm an associate professor at the University of Glasgow. I work at the intersection of human-computer interaction and security. So in extended reality, I'm interested mostly in security, privacy, and safety in XR, so VR and AR. Yeah, that's me. Jan, do you want to go next?
Yeah, thanks. So hi, everyone. My name is Jan Guggenheimer. I'm currently an assistant professor at TU Darmstadt. I'm actually still affiliated with Telecom, so you don't have to scratch it out, Uwe, but it's nice indicator. No, don't worry. So I'm also doing research at the intersection of human-computer interaction and XR, and exploring from the one side the improvement of interaction or let's say haptic techniques for XR, but also starting to explore more and more also with Mohammed issues around security, privacy, and safety in XR. I nominate Sven.
Thank you so much. Yeah, my name is Sven. I'm an assistant professor at LMU in Germany. And my main focus of my research is really in bringing AI systems into user interfaces. And I think with while AR and VR really never got to my skin, I think with cross-reality systems, we're really making this leap where we can incorporate a lot of people around us and make it actually feasible or nice for families and homes and be on the go with these devices. So I'm super excited about this topic. So that's why I'm here today.
And then I jump in for Michael. As I said, he will join in the second half of the workshop. He's a professor at the University of Michigan and is currently also at a sabbatical at the Meta Reality Labs. So I think that's where many people are at the moment. Seems the place to be, I guess. And with that, like, we have one last organizer. Mark, do you want to say a few words?
Sure. So I'm Mark Billinghurst. I teach at the University of South Australia and also the University of Auckland, and I've been doing a lot of work in AR and VR for about 25 years. Also super excited about the new trend towards cross-reality systems, and I'm really excited about what we're going to be talking about today.
Yeah, thank you all very much. So I like kind of just to visualize shortly like how much we are stretched out here in this workshop today. We will have 7 exciting paper presentations. We have 2 keynote speakers and 8 organizers. And there you can see on the map, we're quite spread out. That was also fun while organizing because we always had to kind of manage the US, the European and the Australian time zones for these meetings. And I know that for some of you at the moment, it's in the middle of the night. And I'm sorry for that, but I'm also at the same time glad that you have so much interest in the workshop that you make it nonetheless and that you're joining today. So thank you very much for that. As I said, we have 2 exciting keynotes. We will have one in the beginning and one at the end, and they will be also separately introduced with a short bio, what they're doing, and why are they relevant for the workshop. With the opening keynote, we go a little bit into the direction of prototyping tools and some prototyping insights in general. And with the closing keynote, we go more into the application domain and see a few examples there. Here's the complete overview of the program. So we're currently with the welcome to the workshop. Then we will have the opening keynote. There will be a first paper session. We'll do a short coffee break. Afterwards, we have the demo session and the brainstorming and discussion of future research directions. Have another coffee break. And then in the last part of the workshop, there will be the second paper session and the closing keynote, including like a wrap up at the end and some closing thoughts. So here's the overview of the different tools. I will post the links in the chat in a moment again. I also sent them around via email. I, of course, don't have the emails of attendees that joined from the conference because there was no registration process this time. So we will mostly use Zoom for this. Virtual room 1. Don't get confused. I was because there are multiple virtual room 1s for different days. I think that's how everyone started with the Friday room, and we need to have the Monday room, of course. We will do some breakout rooms here. You can ask questions via voice. Please raise your hand first or directly put them in the chat. But the session chairs will also say something about that dedicatedly. Then we have like Miro, which is like a online whiteboard where we kind of will do, you can have like some sticky notes for the breakout sessions later for the discussion, but you also, so the slides you can find there, you can download them from there. The papers are all listed there. The keynotes are there. You can put like some sticky notes there as well if you have like questions to papers or keynotes, especially if you have like questions that couldn't be answered during the workshop because maybe there are so many that we can't handle them all. So then you can ask them there, and we will make sure that the authors and the keynote speakers will respond to that. And yeah, we will use Miro, as I said, for the group discussions later on as well. And then there is the VRception demo that we can try out on the Quest 1 and Quest 2, and we'll also stream it here into the Zoom. So for everyone who doesn't have a Quest 1 or 2, or is not interested in trying it out directly, then you can just join via Zoom. And yeah, with that, I'm through the short introduction to the workshop and would hand over to Mark for an introduction to cross-reality systems.
Great, thank you so much. And it's a good pleasure to see you all here today. Let me just see if I can share my screen successfully. Oh, wait, hang on a minute. You would think I know how to do this, giving all the lectures I do, but sometimes it does not work. Hang on. Great. Okay. So hopefully, does that look okay?
Yeah, looks fine.
Great.
Thank you.
Okay, so as I'm just as Mark Billinghurst, and I'm working part-time in New Zealand, and one of my favorite things about New Zealand is the beautiful beaches that we have. So this is the beach near my hometown. It's quite unique because it's a black sand beach because we have a volcano near my town. And of course, most of you have been to the beach, I assume. And the exciting things about the beaches is that you have the boundary between the land and the sea. And the most interesting things often happens in the pools at the boundary. So you can see here some crabs and some starfish and a lot of interesting life happening in the pool. And it's pretty much the same for us in the AR VR space. So this is a very old picture I took from Jun Rekimoto, and in 1995 he talked about how we want to make invisible interfaces, and he talked about how AR and VR and Internet of Things all try and do that in different ways. And in many ways, a lot of people researching in the space are focusing just on one of these pockets, the VR or AR or smart devices or whatever else. But the really exciting opportunity happens when you start crossing between them. So of course, we can take these things and put them onto this continuum. And then we have Paul Milgram's mixed reality continuum. And cross-reality interfaces is really about trying to build interfaces that allow us to transition along that continuum or support collaboration between different parts of that continuum. As an example of that, a long time ago, when I first came across this in the late 90s, early 2000s, I was doing research on collaboration, and I thought about how most collaborative VR and AR systems exist as a single point on this continuum. You can collaborate in VR or you can collaborate in AR. But we developed this project to explore how we could transition along that continuum. And the reason for that is because augmented reality is really great for enhancing real objects or co-located collaboration. Immersive virtual reality is really good for immersion, obviously, and sharing views. But sometimes you want to be able to do both and swap in and out of both of them. So we developed a system in 2000 called the Magic Book that allows you to read a real book, look at the pages of the book in an AR helmet and see content popping out, or experience it inside VR. And that way transition over the whole continuum. So let me just show you a quick video of this. And as I said, this is 20 years old now, so it's very old technology. But even though it's quite old, we still don't see this behavior very much in current interfaces, and especially the opportunity to collaborate between those boundaries. So here's two of us watching, reading this book. I'm going to fast forward a little bit because it's, so when we have these head mount displays, we can see AR content popping out of the page of the book and experience it using a handheld display. And then we can, some of the rooms, we could go inside and experience them immersively. So you can see now I'm going to immerse inside the space. So you just look at the AR view, push a button on the display, and we transition into a VR space. But then the most interesting thing happens next. So once we're immersed inside VR, I've gone inside the space, but my friend is still watching me from the real world. So now he has an AR display and I'm having a VR experience. So now we have the opportunity to have a cross-reality experience in that I can collaborate with him in AR and he can collaborate with me in VR. So if I go back a little bit here, you can see now my friend sees me as a little head on this view. And as I move around, he can see me moving. And of course, to make this consistent, I can look up into the sky and I can see my friend looking down at me. And if we want, we can both go into VR together. So that was a long time ago, obviously, but interestingly enough, that happened about the same time as the first mentions of Neil Stevens' idea of the metaverse and Snow Crash. And just like the quadrant I showed you before, there's also this quadrant in the metaverse where you've got these 4 key components of augmented reality, virtual reality, mirror worlds, which are copies of the real world, and life logging, which is using sensors to measure your own physiological state and log what you're doing in your life. And so just like what I showed you in crossing boundaries and creating a cross-reality experience with AR and VR, we can also look at how we can cross boundaries in these spaces. And the technology we're really focusing on is the sensing technology for life logging, capturing technology for mirror worlds, immersive and augmenting technology. But many people, when they think about the metaverse, only think about the immersive state and social VR, but they don't think about these other pieces that offer lots of opportunities for research. So we can imagine what happens when we can combine these different pieces together and create these cross-reality experiences when you bring in pieces from all of the elements of the metaverse. So to give you an example, you can imagine how you could build a system that combines the augmented reality and virtual reality, but are used to support collaboration in the real world. And so we built a system like that a year or two ago, and this system was where you would wear an AR head mount display and live stream a camera view to a remote person. So that's not so unique, and what we did in our case, which was unique, is we used a 360-degree camera. So now when you live stream that view, the remote person can look wherever they like, and the remote person is wearing a VR headset. So now they feel like they're immersed inside your view of the real world. So this created a very nice AR, VR cross-reality experience where you could experience the reality of another person. So you can see here the views with the AR headset, the remote person's drawing on the real view, and this is a remote person who's in VR, and he looks around and he sees this 360 video of him, of his collaborator working in space. Now, one of the challenges with this is that it's only a video, so you can't really walk through the space. So you're not really experiencing immersive VR. But what we've just done in the last year or so is looked at how we can combine together multiple depth sensing cameras, and each of these cameras creates a 3D point cloud, and we can combine the point clouds in real time. So that means the remote person can now walk through a VR copy of your real environment. So you see on the right-hand side here, the first person view, the left-hand side is a God's eye view. And in a minute, one of my students will walk into that space, and we've got a 3D model of him now walking through the space in real time. And so we can use this to create cross-reality experiences between AR and VR. For example, you may want to do a real-time reconstruction to have a person in the real world doing a physical task who's then collaborating with a remote expert, helping him do that task. So in this video, you'll see Prasant, who's moving objects on the table. We've got some depth sensing cameras around the table. We can capture that and stream it to a remote person who's in VR who can help them. So you see here on the left-hand side, Prasant's view in the Magic Leap display, seeing the virtual blue hand telling which object to pick up. Then when she picks up the object, you can see it moves in the real world. And the right-hand side is the real-time reconstruction of the real world. And so you can use, again, this AR VR collaboration to create a very nice example of somebody in AR collaborating with somebody in VR across Milgram's continuum. So we've kind of evolved from sharing 2D video to 360 and now 3D. One of the challenges, though, is you have this kind of trade-off in that 360 video is really good for high quality visual representation, but very poor spatial representation. And 3D reconstruction is pretty poor visual quality because you've got all these point clouds, but high quality 3D reconstruction. So one of the other things we've been exploring is how you can support both at the same time. So the idea is being able to have somebody in VR and a cross-reality interface that can jump in and out of a 360 video or a 3D model of the real environment, depending on what the task is. And so we built a system, but this is kind of a long video, so I'll just fast forward through parts of the video.
In this video, we present our
turn off the video, the audio. So what you'll see here is this is the same as what you saw last time, somebody in 360 helping somebody perform a task in the real world. But the novel piece comes a little bit later when we've got, now we've got a 3D environment. And in the 3D environment, we have these photo bubbles placed. And you can see the bubbles in the background there. And if you click into one of those bubbles, you jump from 3D into a 360 panorama. So you can experience the environment as a 3D scanned image. or you can jump into a 360 panorama and experience at much higher visual quality and live 360 feed, then jump back out again. So it's a very nice example of a transitional interface, cross-reality interface. Then the last thing I want to show you is, almost last thing, is about how you can use this to create new types of collaborative experiences. So in face-to-face collaboration, we can't see where the other person's looking unless we can see their face. But once you start building cross-reality systems, you can add other cues to might enhance that collaboration. So in this case, we have somebody in AR collaborating with somebody in VR with a copy of their environment. But we've added these view frustum lines. So you can see on panel A here, typical avatar with pink head and hands. Then a panel B is the avatar inside the VR environment. But then panel C to E show these view frustrums that show where the avatar's looking. So it means now I don't need to see the avatar's face to know where they're looking. And you can see this video here. The left-hand side is the AR side, the right-hand side is the real copy of the virtual environment. And you can see now this is the AR view, and I can see these pink lines coming out of the person's face. This is the VR view, again showing that view frustrum. And so when we collaborate together, we can see where the person's looking when they're working with me. In this case, they're supposed to try and find these blocks and move them around. So now the person comes into view. But even before I see their face, I know where they're looking, so I can see there's their view frustrum. So if we think about technology trends, I've shown you a few examples of these kind of cross-reality interfaces that support collaboration or interaction. There's a lot of trends happening, and I guess most of you are aware of them, better displays, real-time space capture. The things I'm really excited about, though, is the trends towards combining more sensors into the headset. So gesture sensing, eye tracking, and especially emotion sensing. So you can see, for example, here's the HP OmniSet display, which has eye tracking and heart rate sensing in a headset. And on the right is a Project Galea display, which is going to come out middle of next year. And they have EEG, EMG, EDA, and a bunch of other sensors inside that. And so that means you can do some really amazing things with the sensing data. And of course, just this week, or last week, I should say, the Quest, Meta launched the Quest Pro. And for me, probably the most exciting thing about the Quest Pro was several things, but one is the eye tracking, but secondly, they have this quite good color pass-through camera. So it means now we can use a single device to support either AR or VR, and we can also transition between the two of them as well. So we don't have to change headsets. Here's some examples of videos that are made from the pass-through camera. You can see on the left side, the person goes into the store, puts the Quest on, and then the laptop suddenly is enhanced with all these virtual screens around. On the right-hand side, there's a avatar with a kind of virtual DJ application running that looks like it's part of the real world. And then Microsoft produces concept video of what it might be like with the Microsoft Mesh platform. One of the challenges with this research is always building the systems, and we've built lots of these systems, and it takes us months and months and months to build them together. So Mesh is supposed to be a developer kit that makes it easy for you to build the systems that can be used to support collaboration in either in AR or VR. So let me show you the concept video a little bit.
Connection is a spark that gives our lives meaning. It drives us to seek out others who feel the same way.
Okay, why don't you input the data and we'll take a look together. Hey Mari, what you got for me?
To find those who share our views, yet offer different perspectives.
Look over here.
Challenge us with new ways of seeing.
That I think we should
Deepen our understanding. And enrich our lives.
最后一笔的时候，往前。
Great things happen when we commit to something bigger than ourselves.
Take a closer look at it.
place this here. Let's see how we go from there, okay?
This sense of collaboration and the feelings of connection it brings excites us.
Hey, just in time. I'm gonna move it slightly, okay?
It's yours, take it.
We have two planes right now on the same trajectory.
As we put people first, technology fades into the background and feels like anything but.
So I'll stop playing that, goes for a bit longer, but you can see here's some quite nice examples of bringing people in AR and VR together and having these cross-reality experiences. And that's quite a compelling vision, but Microsoft showed that last year and they were supposed to deliver the developer kit anytime, and it still hasn't come yet. So it's quite challenging to build that. In fact, if you wanted to build this vision real, you'd have to have a lot of different pieces of technology to support. You'd have to have some very good prototyping tools, and that's what we're going to talk about today. Some hardware that would support this, some way to interact with your people around you. You'd have to have some good design principles. You'd have to be able to evaluate how these interfaces really work, and also address bigger concerns like privacy and security. So if we think about the metaverse taxonomy, just like I showed you at the beginning, there's opportunities across Milgram's mixed reality continuum. There's also opportunities in the metaverse space. And we really want to think about how we can focus not just on VR, but expand into the other quadrants, looking at how you can combine AR and VR together, or AR and VR in the mirror worlds and life logging. And by building out for the whole metaverse, we can then look at how we can build these really interesting cross-reality experiences. So just to close, I think cross-reality is really exciting because it challenges us to look at how we can build systems that let people participate from points across the whole continuum, Milgram's continuum, and it also challenges us to solve big problems around evaluation and prototyping and privacy and interaction and the rest. The great thing from my perspective is really new devices coming to support these experiences. You've got devices that have sensors in them like the Galea or the HP Omnicept. You've got devices that support transitions between AR and VR like the Quest Pro. And underlying all of this is the tools that will enable us to prototype very quickly for those experiences. And it's really challenging to build tools that allow us to design for groups or to design for AR, VR together, or combining multiple sensors together. So I'm really excited to be able to see what comes out of the workshop today. And hopefully some of you are building some of the tools that will be able to prototype the future of these types of interfaces. So thanks for your time. Here's my contact details if you want to ask any questions. I'm happy to take some questions now if you like, or we can get on to the more important work of seeing the presentations from other people.
Yeah, thank you very much. I think we have time for 1-2 questions. If there are some, we can do that. Please just raise your hand if you want to ask a question, or type it into the chat. Okay, there's a question from Jan, and since he is around, he could also ask.
Yes, I can. So it's maybe it's a tricky and challenging one. I don't expect that you have the perfect answer here, Mark, but so we had multiple of these, or we tried now to have multiple of these workshops around cross-reality. And I love your visualization that you give. It's this bridge between these modalities that Rikimoto showed, or on the Milgram continuum. And I always try to think about, is there a simple, really trivial definition that we can actually give? What is cross-reality, and how is it different to, or cross-reality interaction, how is it different to just regular AR or AR VR collaboration, or is AR VR collaboration also in this umbrella term that we use for cross-reality systems or cross-reality interaction? So is there beautiful terms such as every time when we have X and Y, then we consider it cross-reality, right?
That's a great question. And I'm not sure I know the whole answer, but and I'm hoping today we'll address that more. But I think for me, cross-reality is really when you combine pieces of, for example, the metaverse, those 4 quadrants, if you take pieces of them and build them so that people can interact together from those different experiences. So for example, if you consider the metaverse with those 4 quadrants, the AR, VR, the life logging, and the digital twins or the mirror worlds, if you had somebody in AR that wanted to collaborate with somebody in VR, then that would be a cross-reality experience. I think if you had somebody who was in the real world using a heart rate sensor and they want to somehow interact with somebody in VR and maybe have the VR person see their heart rate, that's again cross-reality, because you've got somebody who's in reality collaborating with somebody in virtual reality. I think you need to definitely have a crossing of the boundaries, so it's not just somebody in AR collaborating with somebody else in AR, but it's definitely somebody going across those boundaries as well. But I'm happy to be corrected, and I'm happy to broaden the conversation as well.
I like it. Maybe one question that comes up: does it mean that collaboration is an essential part of that? So collaboration has to be at the core of that?
I think doesn't necessarily have to be collaboration, but it could also be interaction. So you could imagine, for example, if you were in AR and you're interacting with a VR or a virtual object, but that virtual object was also represented in an immersive VR environment. And whether or not anybody else was in that VR environment, if I start doing some interaction in AR and the object changes in VR, then that would be, in my opinion, that would be a cross-reality interaction. So so collaborative interfaces are well, most of my research is on collaboration, so that seems like a natural, because then you've got people in both realities trying to communicate and interact with each other. But you could also have, as I said, somebody in performing actions in one interface that will affect another. So for example, if I'm doing some modeling and I wanted to model or create a scene in augmented reality, so I arrange a whole bunch of virtual objects, but at the same time, if what I was doing was also outputting to a immersive VR scene, then that would be a cross-reality interaction. And whether or not anybody's in that VR scene or not, maybe I'll go into it later or something like this. So it's really about crossing the boundaries between, the different points on Milgram's continuum.
Thanks.
Right. Hopefully that, I'm not sure that confuses people or clears things up.
Yeah, I think it's a good step in the direction. I'm not sure if there is actually this clear definition, but yeah, thanks. I appreciate it.
No problem. I'm happy to take other questions, or we can go on to the other presentations if you like. I'm excited to see other people's work.
Yeah, I think there is no more. There was one, maybe. So yeah, go ahead.
No. I just thought there's no more questions, so I think we could quickly and swiftly move on.
Yeah. All right. Good. Then thank you very much, Mark, for the very nice introduction.
No problem.
We hand over to Sven for the introduction of the opening keynote.
All right. Correct. It's actually my great pleasure to introduce our first keynote speaker of the day, Herman Leiva, and he's an assistant professor at Aarhus. If you could wait that everybody sees where you are. Yeah, there he is. Great. And I think while I get some other extra words, it's probably a good idea to get your slides going, right? Cool. And yeah, so why is this a great pleasure for me? Of course, because of his work, but actually also we have quite a number of years going back together. It's quite nice when we were student volunteers at Kai, and almost 10 years back when we met the first time. And of course, since then, he's also doing great research. But I think what makes him even more interesting for us here today to hear from is he has a vast industry experience. Actually, he started in industry first, and only later came into research. So he went to a number of Telefonica in Argentina, and Google, Siemens, and Tobii, and only within that space he started actually pursuing the academic career, which I think also shapes his research, and I hope it will shape this talk as well, to give this bits of insights of him developing in the real world, because I think that's always inspiring to see how we then come from prototypes, because today is about prototypes, but at one point we hope that on stage Meta shows our stuff. That would be a great step in the right direction to bring all of the things that we envision today into people's hands. And with this, I'm very pleased that you're here today, and the stage is here, Herman.
Thank you very much for those kind words. I want to check if you're seeing my slides or my notes, because it's kind of not clear for me at the moment.
So far, it's black on my end.
Okay, so let's try again.
So I'm seeing your notes right now.
Now it's your notes.
Yeah.
Now it's my notes. Yes.
Yeah.
Let's do it the other way around.
That's if you go full. Yeah. Perfect. There we go.
There we go.
Awesome. Well, thank you very much again. It's so nice to see so many familiar faces around. And let's try to talk about something very general, actually, and let's see where we go from here. So I think we love prototyping. That would be my starting point. But however, I think sometimes we mix prototypes and prototyping So I will try to dwell a little on these terms and try to hopefully inspire you to look into different directions. So if you look into theories of prototypes within HCI, there are definition of prototypes, concrete representation of part or all of a system, or other people like Lim. They see them as filters of a design space and manifestations of design ideas. Usability engineering, like Jacob Nielsen, they talk about horizontal prototypes, the idea that you cover many features, maybe if you want to describe a scenario, or vertical prototypes when you want to dwell in a particular task. Right now, super popular, we talk a lot about high fidelity versus low fidelity prototyping. If you look in the history of HCI, you can see there was a big debate about these terms. Right now, I think we are condensing many things within these two ideas. And interaction design in general, it's focused on many areas, not only in one aspect. So is it high and low level in the form of the prototype, or in the content of the prototype, or in the behavior of the prototype? And generally, these use different kind of disciplines to explore these dimensions. So I will dwell on that later. If we don't use fidelity, we can use precision. Other people use resolution. And I think that the main takeaways when we talk about fidelity is the idea that whatever you're representing is very close to the final product or prototype that you have in mind, but sometimes you're using prototyping during ideation. So talking about fidelity could be tricky. I use fidelity anyway because it's the most popular term. Others said, no, we should look prototypes and their role in the prototyping process. It's about how the prototype will look and feel, or what is the role of the user, or how will we implement it. And they can position prototypes within this representation that has 3 axes. But it's not only about the artifact that we are creating, it's also the process. So then we have prototyping. And it's very important to understand what is the approach that we are taking, or the purpose that we have for this prototyping activity. Early on, Christine Floyd mentioned these 3 approaches: exploratory prototyping, experimental prototyping, and evolutionary prototyping. Exploratory, the idea of maybe using prototyping for ideation, looking for quantity rather than quality. Experimental, more related with evaluation and testing. And evolutionary, related to the idea that the prototype that you are building will be transformed into the final system later on through many iterations. Others, like Baxton's, they don't like that much the word prototype for ideation. They use the word sketching. So we need to be mindful of that. If I compare that with what Floyd was saying, my take, it's like sketching, it's like exploratory prototyping, and prototyping for Baxton is more like experimental or evolutionary prototyping. So again, you need to kind of say in which view of this prototyping process you are in your papers. And for us, that we are talking about cross reality, augmented reality, virtual reality, there are things like the experience, and prototyping that has many other challenges. There is this paper from IDEO a while back ago that they mentioned this idea of experience prototyping. And the goal at the time, and I think it's still today, is to put yourself in the shoes of the designers and in the shoes of the user, and how you can make that part of your prototyping process. They have a nice example of having some medical conditions and then taking notes of where that will happen will be triggered by someone calling you or sending you a notification. Like, for example, you are having a heart attack right now, and then you need to react to that. So how is the experience of doing that? That is an extreme example. Okay, so we talk about artifacts and we talk about processes, but what brings me here right now is talking about what are the tools and the techniques that we use for building those prototypes. So I will show you a huge table, but for no means this is trying to be exhaustive. But we can see here something that is based on a taxonomy from Boudin Lafont and Wendy McKay. And I will try to have some animations to drive your eyes to parts of this table. So at the top, we have like 4 dimensions: evolution, representation, precision, and interaction. And in the left, we have a bunch of tools and techniques. So evolution refers to this idea that the prototype, the life cycle of the prototype, it's something that it will live like a couple of minutes. We will use it for some kind of ideation, or we will have many, many iterations. So we talk about maybe rapid prototyping and iterative prototyping. Rapid prototyping generally has a lot of use of throwaway prototypes, something like paper prototyping. That takes us to the second dimension, that is the representation. And for us, that in XR, I'm seeing a lot of focus on software prototypes, but there is a big category of paper prototype. And when we say paper, we don't only mean paper, we also mean physical mockups, having something with Play-Doh or cardboard. And going back to the point that I make at the beginning, interaction design has many dimensions. And in here, I put only 3: content, form, and behavior. And we can have a high and low fidelity in any of these dimensions. So we can have some of these tools and techniques, they focus more on the low end, maybe medium, maybe high. And the last dimension is the one that is called interactivity. And sometimes we don't need to have an interaction in our prototype to convey an idea or to explore something. That is the role of pen and paper or physical mockups, or video prototyping, like the concept video that Mark showed us. That prototype for us is not interactive, we are just watching it. But then we have a whole spectrum going from none to fixed to open. Okay, so that is a design space for us as creators of prototyping tools. I want to make one point about pen and paper. This is some work from 2010 that was saying that still pen and paper was one of the most used mediums to prototype. And if we see the current landscape in 2022, we still see a lot of use of sticky notes, paper prototypes, storyboards as part of the prototyping design process. Now, how we transition from those paper mockups to an actual interactive representation, I think there is open work for that, but it's something that I think researchers, we are not focusing, not many researchers at least are not focusing on that area. Some exceptions include, for example, Michael that is doing some work on this too. I will paint something based on more current, more traditional applications like websites and mobile apps, but I think many of these insights might apply also to XR. So this is just another design space that is using 2 axes, one about the prototyping speed and another one about the dynamic behaviors that they provide. And as I showed you before, many of these tools are still used in XR prototyping. But for example, pen and paper will be a technique that is very fast to use, but it only provides static behaviors. Then we have things like Figma that started as a web-based vector graphic tool, but is moving more and more into dynamic behaviors. Then you have programming, you can use Unity if you want, or high-budget video prototyping like concept videos. But I was very interested on the top right quadrant. How can we have something fast, but also providing some dynamic behavior? So I will give you some examples of explorations that I have with prototyping tools in that region. If you have any type of HCI course and you want to do video prototyping, we have a tool in the App Store that is called the HCI Video Clipper tool. It's for traditional video prototyping, but it's available. You can download, use it with your students. It's completely free. And then I will mention these 3 other tools: Montage, Enact, and Rapido. So let's start with Montage. Montage was a tool that started to help designers to create video prototypes, but not only with paper, also allowing them to have some kind of digital sketching. So we were using that to prototype some early augmented reality menus on your hand. And also you can have some type of creation of objects and scaling them with some kind of meter gestures. Again, this is all fake. This is a video prototype. It's not a system that it was actually implemented, but you could do this type of prototyping in a couple of seconds. So how does it work? We have some user actor with a user cam and a wizard that is using another cam that we call the wizard cam on a paper prototype. And we combine these two video streams in a canvas where the wizard can create different sketches. So my first takeaway is provide multiple point of view for the designers. Sometimes you need something that is more related with computational representations, and sometimes you have something that is more related with the final visual look. So in montage, we have this separation between the interface and the context of use. And the glue between these two, it was just green screens. So the system detects any green screen in the user cam and replace that with the interface that you are drawing on the right. Now, if you create or put a paper prototype in the paper prototyping area, that will be replaced in the final video automatically. And you can also sketch things in the context to show like speech bubbles or notifications, or sketch things in the interface area to add elements to the, in this case, the mobile application. So basically we have the sketches plus the paper movie that will be the interface movie, and the context movie with the interface movie will make the final movie. The takeaway number 2 will be to maintain a single source of truth. Whatever you are drawing in the interface will be replaced in the final video automatically. And that helps later on when we talk about collaboration between multiple stakeholders in this prototyping process. So one of the benefits of having this glue with this green screen is that we can use the same interface and apply it to different contexts. Evaluation is a huge part of XR prototyping, and letting us explore how one interface will look in different situations is essential. So providing means in your prototyping tool to doing that, I think, will be key. Okay, so this was just video prototyping, old school sketching on top of a 2D video. How can we use AR to create AR video prototypes? And that is the second project that I want to show you, that is called Pronto. This was done in collaboration with Adobe. So at the time, we interviewed some experts, AR designers, and they told us that they have many tools to create high fidelity assets, but still it was tricky to handling the changing position of the user when they were prototyping. And positioning 3D assets in a desktop computer, it was tricky using these different widgets to move things through depth. And finally, they also mentioned a lot of pain points related with animating assets, and particularly keyframing animation. So with that in mind, we have these goals, creating a low fidelity asset, capturing the position of the user, positioning things directly in 3D space, and creating custom animations. We added one more, that it was creating a low barrier for any designer to use these tools. And for that, we decided to use a mobile device. We were using sketching, we were using video capture, and direct manipulation for both positioning things in space and creating animations. So I will show you a little video sample of that right now. Can you hear the sound? No, because
no,
I didn't.
No sound at the moment.
Okay, well, I will do the voiceover. So if you want to prototype in AR a camera movement, like approaching to this object and getting some kind of UI, in this system, in Pronto, you can use your own iPad on top of a recorded video, and now you can navigate that 2D image in 3D space. So you use your device to say, for example, I want to create a sketch on the left side of this object. You create this placeholder. You take the stylus, and you can directly draw on the placeholder that you just created. And then you have like show and hide timings. And now when you get closer, you get the asset. And when you get far away, the asset disappears. So my third takeaway with this project will be that it's a little in contraposition with ubiquitous computing and some of the goals of augmented reality and virtual reality, making things invisible. In here, at least for prototyping tool, I think we need to reveal some of these invisible things to let the designer actually manipulate them. Which one and in which capacity, I think it's very dependent on the context that you are using. So in this case, we were using the tablet as a proxy of a design tool. You can use it to create animation, you can use it to create assets, and a lot of these things we're doing by example, by demonstration, and I will show some of those later on. And a final point, I think I still have time for a final point, is looking at how professionals transition from these designs or early prototypes to actually interactive prototypes. And many of the findings, again, were from traditional websites and apps, but I think they might apply still to cross-reality interfaces. So I will be talking about the designer and the developer role, but that doesn't mean there is one designer and one developer. No, there could be many designers, many developers. Sometimes we have these unicorns, sometimes us, that work as designers and developers at the same time. But we need the representation to manipulate these different aspects. Again, if we look at the current landscape, we have paper prototyping, we have mockups, we have video, we have many, many, many different representations in the prototyping process. So the results of this study that we did with many designers and developers for different areas was, one, there is a lot of rework and redundancy. And I can see this again in XR prototyping. Things that the designer is doing, they need to be replicated by the developer. And in that replication, many things get lost. There are many design breakdowns, the specification, the brief, whatever you want to call it, when it's sent to the developer, there are problems. And these problems, we found that can be categorized in three main categories that I will show you later. And the last point that I want to make is the participation of the developer in the process. Long story short, if you have something that is very custom and very exploratory, if the developer is not involved in the beginning, those projects generally tend to be impossible or complicated, let's say. So the design breakdowns that I want to mention are the three: missing information, edge cases, and technical constraints. So the designer will create an artifact and send it to the developer. And sometimes the designer will think on a case, on a situation, but that case and situation is not reflected on the artifact that is sent to the developer. We call that case missing information because it requires the developer to communicate back to the designer. Then we have edge cases, and this is a typical one. The design only covers sometimes the sunshine cases, but something like the internet connection is lost, or if you have very high number of items in your list, that is not covered in the design specification. And developers, when we are developing, we generally think in these cases more often. And the final one is technical constraint. Now, the design includes something that cannot be done either because of limitation of the device or skills on the developer side, generally time. Okay, to mitigate those breakdowns, we proposed these goals at the time: encouraging early participation, reducing this rework and redundancy, mitigating breakdowns, and supporting going from examples to actually rules for interactivity. And there is a one-to-one mapping to the takeaways that I was just telling you before. Multiple viewpoints will help you make other stakeholders to participate. A single source of truth will reduce this rework and redundancy. Revealing things that are invisible should expose some of these edge cases. And finally, support by inaction, that hopefully you saw it throughout the different examples, is the idea of using demonstrations during the design. So a term related with programming by demonstration, but the end goal is not programming, it's actually design. So to finish, I will show you one last example of a prototyping tool. This one is called Rapido. And it was, again, to create interactive video prototyping, not only like watchable video prototypes. So design by inaction in this case, for example, if we want to animate this lamp, it's just a simple press of this animation mode, and then you can draw the animation with your fingers. The multiple viewpoints, we have a mobile AR experience, but we also have a website that has a timeline view to transition from this video prototype to an actual interactive prototype. Every demonstration that the designer was doing is saved in this timeline, grouped by the sketches on the left. So you can see that we have a catalog, a button, a marker, a lamp. And on the right, we have all the different demonstrations when each element is shown is hidden. And finally, the system will use that timeline and group the demonstration by states and create an initial state machine that create the basis for the interactive prototype. Then you press test, and then you can have the actual interactive prototype live in your mobile device. And you can use the state machine on the right to debug, for example. Now you know that you are in the placing state, and then you go to the observing state. I show you 4 design principles, and I want you to recap. Be mindful of the different dimensions of interaction design, be mindful of the terminology, and really have in mind what is the purpose of your prototyping exploration, maybe for ideation, experimental prototyping for evaluation, and evolutionary prototyping to reach a final product. Thank you very much.
Wow, thank you so much. That was a great talk. All right, and with this, I guess we have like 10 minutes of questions. I know we're behind schedule, but I think we started late. I think 10 is what should be fine. All right, and then we have actually the first question also in chat here. And the question would be if the 2 tools or the 2 projects you showed, are they available for purchase or download?
Well, that is the burden of being a researcher, right? So if you send me an email, I can get you pronto. Rapido is in a state that yeah, let's say if you have some postdoc that want to work with me, we can make it available.
All right. All right, so the easiest I think is just if you raise your hand or just unmute yourself. I think we're such a small group, and I think a group discussion for the next 10 minutes or a bit like more interactive, not only silently sitting for all of our screens around the world would be nice. So, and Jan is the first. There we go.
So thanks a lot for this really cool talk. Shaman, you had this split at the end again between designer and developer, and I felt that these tools that you presented aren't they kind of bringing this to one? Is this a desirable goal that you don't have the split, that the designer is actually able to have the tools to be the developer, right? With this ability to actually have not like, as you showed, actually maybe high fidelity coming out of it, like these really good functioning ones, that you have this one person that is the creative mind behind it and has the power and the tools to actually create. I felt that Unity did something like that, right? I mean, 3D engine. And usually if you like start opening whatever OpenGL and try to create VR from there, is incredibly difficult. But with Unity now, everyone just with scripts is able to create like really good systems and kind of putting it to the extreme. Is it something that we want, right? Kind of having this role in one?
So there are many things there. So in here, I was taking an approach of being in that top right quadrant, that the idea of being fast and allow you to do custom things. I think I have a backup slide actually. Yeah. Like you have some tools, no? Like right now, like you have something like Spark Studio or Lens Studio, where Torch actually is not anymore, but Reality Composer. And a lot of people use this phrase, now having the keynote for XR. And I think that is lowering the bar to letting the designer actually being able to showcase something. I think one of the problems with that is when we go too much to the standardization. So when you standardize things, sure, now it's available for more people, but everyone will end up with the same interfaces. And I think that is repeating the history of WIMP interaction, no? Like why we don't have radial menus? Well, linear menus are dominating everything. So how can we provide tools that let the designer, the creative, propose new interfaces, but not only in sketches, they should be interactive. Now, if we go to Unity, I think there are ways of playing along with them. No, you have file formats for 3D scenes, but they don't cover interaction that much. Like I've seen GLTF or USD, USDC, they're going maybe there. I'm not sure how that will happen, but we need that. We need more integration between these tools. So if some designer is working on the keynote for XR, they can transition to the developer tools. I don't know if I'm answering, but that's what inspired me, your question.
Yeah. No, thanks. Maybe the last one is, do you think that's a desirable thing, right? To kind of have this one tool for the people. Is this something like good or no? No.
I'm not sure what is good or bad at this point. We need to see. I think having multiple tools is something that, you want it or not, will happen. So the goal is to make multiple tools work alone, like work together. I think that should be the aim, not to have a one tool rule them all.
Thanks.
All right, thanks. Mark, I have a question.
Oh yeah, so really nice work. I really love the prototype evaluation tools you're developing. I'm just wondering, or prototyping tools, I should say. I'm just wondering, how do you evaluate the prototypes? So you built some very nice prototypes, but how do you test them and decide which features working well, and use that to iterate and design your next version of the prototyping tool?
Yes, that is a really good question. So you have different. I don't know how much can I do improvisation here. I can share you. There is a paper that is talking about evaluation methods for prototyping tools. There are different ones. The most used one is called evaluation by demonstration. That word is used a lot. So you show how the variety of prototypes that you can create with your one tool. That is one measure. Then you have a heuristic evaluation. You can show if it's faster or it's more performant. The typical one was having the same task and showing in Unity you are doing it this way. With my tool, you are doing it this way. But we know when you create a prototyping tool, it's tweak for that particular task. Personally, I don't think that is a great way of evaluating. And what was the other? Demonstration, heuristics, and there are two more categories that I cannot remember from the top of my head. What were the other? Well, you can do an actual control experiment, and I don't remember the other one. But I think we need more. I think with these tools, it's having them in the wild for a little longer, and that is the benefits that these companies have. No, they have Spark Studio for a while now, and they are adding different things that are being researched. Same with Reality Composer. And I will share on the chat the paper that I'm mentioning. You are muted, Sven.
Microphone this morning, not my friend. Okay, I'm trying to get that all of my life into physical, right? All the lectures will start today in physical, but let's have this one in Zoom with microphone on. Okay, so I think you showed a vast amount of insights especially in the first half of the slides, of like all of the different insights over the year. And I wonder, like, let's imagine I'm a first-year PhD student. Like, how should I navigate the space? Like what do I do? Is there a guide, a handbook? Like, how do I get everything in my head? What would you advise to like get going?
Read my PhD thesis. That will be my.
And I hope you also have a short teaser for that.
No, I think we need to, something that I maybe this is an invitation. You know, like the table that I show you is actually quite outdated, I would say. It was trying to be exhaustive, but it was using some terms that they were using user interface management systems. No, we don't have those anymore. We have, I don't know, IDEs. So when you start reading those papers, some things like what is a user interface management system? So I think we own to the community creating some of these taxonomies a little more up to date. And particularly, I will be interested on mapping these things to XR tools. I'm showing you here just a list, but what are the benefits and disadvantages of these tools? The problem, they are moving so fast that we cannot catch up. So you need to read some of those basic theory on prototyping. They're really easy papers, to be honest. So that is one of the benefits. That's not crazy technical reading. But then when you start digging in the tools itself, you are opening a Pandora box. If you go to research, where the things like, I don't know, Jan is doing, or some other people are exploring haptics, or some other people are brain-computer interfaces, like, yes, you need to pick your battles. If not, it's overwhelming.
Right. That makes sense. I think to get started, it would be nice if you could share your slide, actually. So I think that would be a helpful start. And it's basically a short, condensed version of your thesis. That would be perfect. And with this, I think are there any more questions? Otherwise, I think we would start with the papers. All right, there are no more questions. And thank you so much for being here this morning and giving your insights. Thanks.
Should I go on right away, Uwe, or you have a segue prepared?
I have a slide deck where it shows like which papers are in the session now.
Oh, nice.
But let me, there you go. So yeah, so the next session is our first paper session, and will be introduced and moderated by Jan Guggenheimer. These are the papers that we'll have, and I'll hand it over to you, Jan, to take it from here.
Thank you. What we will do is we will, as this slide nicely shows, we'll go through all the talks first, and then we have a 10-minute discussion afterwards. So please, if you have any questions, just write them to the chat. You could use the Miro that Uwe shared before. And if you write the questions in the chat, you can read them yourself, but also if it's uncomfortable for you, I can also read the questions. So please think about what is interesting or what is work, and please write your questions in the chat. We will start right with the first paper, which is visual coherence for cross-virtuality analytics. And the presenter, as I have it written here, is going to be Christoph Antes, right? Christoph, you here? Or is Fabian presenting? Fabian Ponteca.
Hello.
No, Christoph.
Hello.
Okay,
yeah,
perfect.
it's actually me. So Fabian unfortunately has a different appointment also at ISMAR today, so he won't be available, and I'll take over the presentation. So I hope this is fine. Just a second. So can you see my slides?
Yes.
Okay, perfect. Okay, so my name is Christoph Antes. I'm going to be speaking on behalf of Fabian Pointecker, the first author of this submission. And I'll share our ideas on bringing concepts from visual coherence into the area of cross-virtuality. So I'm not sure whether all of you are familiar with the visual coherence topic. So it's a well-known area from augmented reality, but very specific to augmented reality. So the idea of visual coherence is to embed augmentations in real environments in a way that they form a coherent image. So you got aspects like occlusion. Virtual objects in AR could be occluded by real objects. You get aspects like lighting and shading. So you will have the same light, lighting on the virtual object as you would have in the real world, ideally. And of course, you can combine the knowledge between the knowledge about lighting in the real world and geometry in the real world to generate aspects like shadows, reflection, and refraction. And
Fabian, a quick, sorry for quickly interrupting you. I think your slides are not in full screen. You're currently sharing your screen. Your slides are not in full screen. We see the PowerPoint, the whole PowerPoint environment in your eye.
Okay. Sorry about that. Let me try to fix that. Just a second.
Don't worry.
That's the presenter view. So, sorry. Does that work better?
Yes, now it's good. Thanks a lot.
Okay, perfect. Okay, sorry. Thanks for the reminder. Sorry. And currently we can see really big trend coming in the area of cross-virtuality analytics. So we've been working with several research groups together on a survey which was published this year and investigated papers touching cross-virtuality and specifically in the domain of cross-virtuality analytics. So where you combine cross-virtuality or cross-reality, how it is sometimes called, together with immersive analytics. And you can see there's a vast amount of papers, or quite a big amount of papers coming up in the recent years. And we believe this is also because the technology is ready right now for that. So I'll talk a bit about now on visual coherence. So the ideas we know from augmented reality to combine them together with cross-virtuality in two different aspects. First, for generating transitions, and second, for supporting visual analytics. But let's see first some ideas on now I'm stuck with the presenter view. Sorry about that. So let me talk a bit about the concepts that you have in visual coherence. So first of all, there's the problem of occlusion. If you simply place an augmentation in the real environment and you would have the augmentation in front of a real object, you would simply overdraw it. So you don't want to have that aspect. So you want to cut out parts of the augmentation to reduce the problem of overdrawing. And for that, there are many approaches in AR available, like using depth sensing, imposter or phantom objects. There are approaches like optical flow analysis and object extraction. In terms of lighting, there are also a fair bit of there's been a fair bit of research going on to provide the correct shading of the objects. So what you see here in this illustration, these are some examples how this could be done real well. On the right-hand side of the images, you see the real-world object, and on the left-hand side, you see different approaches to get the shading correctly. And to get information about the light sources, you could go via light probes, for example. There are some very simple ideas. They use GPS coordinates. So if you know where you are, often the sunlight is the most intense light source when you're outside, most definitely. And if you know where you are and you have the time, you can use that data to use correct light source position and direction. Glint detection in the eyes is a bit more tricky. So if you have face recognition, and you can try to detect the highlights in the eyes to get ideas about the light sources, or you can simply pre-model the environment. Well, why could this be helpful or useful to have that information? And there are several ideas where you can actually use that, for example, for enabling visual transitions. So if you have information about geometry, for example, we could use this geometry data, as we'll see later, to create more transitions. So what are visual transitions? Here are some examples which we will present on Thursday at ISMAR. So we do have 4 different approaches which we evaluated. One is fade, where we are moving via simple color fade or fade between augmentation and virtual reality. We got a clipping plane, cutting plane, cutting the real and the virtual environment. We got approaches like the teleport beam, which comes from the idea a bit from Star Trek, where you get teleported from one environment to the other. And we got portals which visualize the other side of the environment. So either the real or the virtual, through which we have physically to step through. So we can use these aspects of visual coherence for the different transition techniques, for example. But so what were we looking at? You all know Milgram's reality virtuality continuum. We've seen that several times adapted on the slides today. But in this paper by Paul Milgram, there is another aspect, which is the so-called EWK, the extent of world knowledge. So Milgram talks about classification, further classification of mixed reality applications besides just between real and virtual. And one axis he describes there is the extent of world knowledge, ranging from a fully unmodeled world to a completely modeled world. And this information we get from the visual coherence algorithms, from the depth sensing, scene sensing, environment sensing algorithms. This is something we can use basically to fill the extent of world knowledge by separating it into geometry and also into lighting information. So geometry, we can have a high resolution mesh of the real environment, ideally. So starting with simple aspects like getting the boundaries of the room or having data about physical objects. We could extract data from the real environment like material properties, and we might also be able to get information like semantic data about the object. So if you're available to know that this geometrical representation is a table or a chair or something like that, it could help us. In terms of lighting, we will have, in most cases, as you get it already from ARKit or ARCore, basic lighting information like the ambient light, but it would be really desirable to have more detailed information like position and direction. And we could also have information about point lights, about the type of light source, like point lights, directional light source, and several other attributes. So if you try to sketch that in a graph, you basically split up the extent of world knowledge into lighting at a very simple level, just having that data about the ambient light, and also at a very high level where we know what light source it is, what attributes does it share. And same with the geometry, so low fidelity here, where we maybe know the room boundaries, and high fidelity, where we are able to classify the objects. And with that, there are several things doable in AR, like rendering shadows, having refraction and reflection. But we also believe that we can have in general advancements in cross-virtuality applications, but also develop new transition techniques based on it. And I'll talk first a bit on the transition techniques and then move to the general advancements. So here you see some examples from the domain of cross reality. I would already say, so there was an early project from the Meta demonstration this year, or demo project Cambria, the World Beyond, the demo was called, and where people were making use of room boundaries. So they're detecting the walls of the environment to transition the walls and basically open up spaces in there. It would also be possible with geometrical knowledge to have objects disappear and reappear in scenes, for example. Then we know, when we have information about lighting, transition techniques could be implemented, which would be flashing, for example, just providing a light flash from the direction from real-world light sources. Or we could work with more sophisticated techniques, as you see it in movies quite often, with overexposure techniques, and move the data in between there. Another possibility would be having the data about geometry and lighting as well. We would be able to render, for example, caustics and refraction, as you can see in this example. So having portals, water portals, and things like that. So it opens world knowledge, opens a vast amount of potential new transition techniques. In general, there are advantages in having visual coherence, and I think this is an area which should be investigated in depth. We know that lighting can improve the perception of 3D structures, and if you think about visualizations, moving them from AR to VR and vice versa along the continuum, it would be ideal, and we also believe that it would be crucial to have a consistent lighting in between these data sets. There are also aspects like going into the direction of photorealistic visualizations, and also including data from or objects from the real world into these visualizations. There are, of course, challenges in terms of color perception, color blending, so you would have to match these colors correctly when moving along the RVC. And when working outdoors, we have the well-known problems of optical see-through HMDs. So what are general the problems in this type of data acquisition? So geometry, we have often dynamic scenes, we got moving objects, humans in the scene. So that is hard. We've seen approaches by Mark presented earlier today. This is hard to tackle to get fine-grained resolution match. And fine-grained meshes, of course, might lead to performance issues. Getting the lighting information consistently is challenging. So there are many approaches described in the AR domain, but having this in real time at a very high fidelity, this is still challenging. And the problem is that we have consistent updates which we have to perform, because lighting might change, geometry might change, and there are a fair bit of things to work for. So, but the key takeaway is think about using visual coherence approaches from the AR domain to enable more sophisticated transitions and use them in cross virtuality in general. And that's been it from my side. So that's the main address. Yeah.
Oh, sorry. Thanks, Christoph. So as I mentioned before, we're going to transition through all the papers, and then we're going to start the discussion round. So let's thank our presenter. And the next paper is going to be Labscape, a prototype for enhancing play experience and cross-reality gameplay. The presenter is going to be Michael McCreed, and the authors are Alexandra Kovaci and Luma Taba. Michael, yes, I see you're here. You can start sharing your slides.
Hello, can you hear me and can you see my slides?
Yes, looks good.
Awesome, thank you. So as it was mentioned, my name is Michael McCready. I'm a grad student at the University of Kent, and Alexandra and Luma are my supervisors. They aren't here today, but I'm presenting on our behalf. So I just want to talk a little bit about, so if I just quickly talk about the project that I built a prototype that is a cross-reality experience here in gameplay. And so I'll be presenting some of my master's research with regards today. So when I was doing some of my research, I discovered because of the pandemic, we've seen a huge increase in the interest in multiplayer games as people were trying to find ways to connect as they weren't able to leave their homes, and they still needed to have those social connections. Excuse me. But we've also seen, because of that, the pandemic, an interest in the interest of virtual reality gaming, again, for a similar reason, where people were trying to connect, have an entertainment and enjoyment as they were confined to their own homes and not able to socialize. But even with this huge interest and with the immersive qualities that virtual reality HMDs have, they've received criticism, as we all know, for things like their isolating characteristics and for the discomfort that they can cause. And so because of these perceived challenges and challenges, researchers like ourselves and developers have begun to look at ways that we can introduce novel interactions by including bystanders and by including others who maybe are not part of the virtual reality experience, as you can see in this photo here from PlayStation VR. But being able to just port an experience from one platform to the other without considerations of what that platform offers, the limitations, the affordances, will result in a poor player experience. So here's a screenshot from a research paper where they looked at an early port from Skyrim, the Microsoft game or the Xbox game, into VR. And you can see in the red highlighted areas that in this initial port, I think they've had these issues fixed now. The user interface was too close to the player. It was cropped by their view because it just wasn't considered the limitations, or not so much the limitations, but the way that a player would view in VR. And so when we think about the approach to develop a cross-reality system that's going to have different access points to that system, there is a complex layering of theories and concepts that need to be considered when developing these interactions that are going to be experienced on a variety of devices, whether it's virtual reality, desktop, or augmented reality. So as I started to look at my master's research, I started to look at what theories and concepts need to be considered, and really looked at developing a scaffold approach where each concept or each kind of theory built upon the previous one. So initially, I looked at generic game theories. And so here are some of the theories in my research that I looked at referring to. So the MDA framework, which if you're involved with game design at all, you're familiar with. Swink's model of interactivity, and then flow theory, which is also a very well-known theory when it comes to not just to games, but other user interactions and user experiences. But looking at that, then we looked at, because cross-reality has more than one person, what are some of those multiplayer concepts or multi-user concepts that need to be considered? And so looking at Kay's group flow, which looks at a little bit similar to the flow theory, but then more so in regards to user interactions, collaborations, as was discussed earlier. And then from Harris, looking at the asymmetries and interdependencies that can be experienced either because of just the sheer nature of the devices and their limitations and affordances, but also the ones that are designed and contrived to be able to create new ways of interacting and new ways to collaborate together. And then looking at, because these experiences are going to have immersive qualities, I looked at theories related to embodiment, presence, engagement, and immersion. And while there are similarities, there are some differences along those, and looked at, with each device, how can they support and encourage these theories here, whether you're connected through an augmented reality device or a desktop PC or a virtual reality. And then taking all these kind of theories and these concepts together, then looking at what are the complexities when working with a cross-reality system. And so there were 3 papers that I looked at with regards to this. And so there was one that kind of shared the taxonomy of asymmetric interfaces and how do these devices, what are the affordances that these devices can offer when looking at the way you will have interface and interactions. Another one is the composite framework for asymmetric VR. And then the last one being a best fit framework for asymmetric multiplayer VR games. And so when I looked at all these, I started to then use that as a guide for the prototype that I was going to build and the ways I was going to try to encourage and increase player experience across the different devices. And so the one that I really built a lot of my research on was this best fit framework from Rogers et al., where they looked at over 200 papers and then whittled that down to 25 of research papers that looked at developing asymmetric VR gameplay or cross-reality gameplay. And then as you can see in this from this graphic, their framework looks at pulling from a lot of different theories. Some of them I referenced in one of my earlier slides. But as they looked at these research papers and these cross-reality experiences that were created, they did identify a few gaps, which is part of the basis for my research. And some of those gaps are, in most cases, group flow was rarely considered, and how those experiences would be affected through multiplayer. Most of the ones that were looked at really focused on two individuals or two types of devices. And then very few focused on remotely located. So a lot of them were co-located experiences where they shared the same physical space. And in a lot, if not most of the research papers that were reviewed, the narrative impact on the player experiences was not researched. So the prototype and the research that I'm looking at will address these and as in the way that you see identified on the screen here. So my research questions for my master's thesis are, well, what factors affect player experience in the remote cross-reality game? And then how is player experience affected by the embodiment and interaction limitations and affordances of VR, AR, and PC devices? So I'll just go show you a couple screens from the prototype. So here we've got 3 players. So when they join it's a cross-reality escape room type experience. And each player, the VR player represents a protagonist who is the scientist in the laboratory, where the PC player represents a security officer who has access to a number of security cameras and can provide information to the players. And then the augmented reality player is represented by a drone who is actually in the space with the virtual reality player. And then here's just a bird's eye view of the prototype. As you can see, the VR player and the AR player here. And then the PC player is embodied through a number of security cameras that are throughout the environment that we're able to actually toggle through and speak to the players through the security camera. So the research that I looked at, I took the mixed methods research design approach where I looked at qualitative. So through the process, I would interview each participant after they had gone through the experience, and then also did video observations where I recorded them and currently in the process of doing the thematic analysis component with that. And then I also did a quantitative analysis where I looked at 2 pre-existing surveys. So the GUESS 18, which is the Game User Experience Satisfaction Survey, and then the multimodal player presence survey were ones I looked at from a player experience and a social presence perspective. So I had 24 participants, 15 male and 9 female. And here's just a screenshot of one group. They were in groups of 3, and we've got our VR player, our AR player, and our PC player, all in the same experience and interacting together. So when I looked at the quantitative, when I pulled in both the GUESS 18 and the multimodal survey, the multimodal had a total value of 20, and I conducted a one-way ANOVA through SPSS. And there were no, there were no statistical significance differences between the devices. You can see a graph here of the total value for the social presence experienced by the VR and AR players, and VR slightly higher and the AR and PC players slightly lower. But again, no statistical significance in the differences between these 3 devices or these 3 players. And then looking at the GUESS 18, which is the user experience, again, I conducted the one-way ANOVA, and you can see the numbers slightly different between the different players, but again, no statistical significance between the devices experienced there. So I've currently started my thematic analysis. The preliminary findings kind of looked at some of the key findings here. So the hidden profile paradigm or asymmetry in information created independencies between players, which fostered team communication. So an example here is the VR player has to adjust this power panel with these levers and buttons, but doesn't know the configuration, and the sheer potential variations would make it impossible to do on their own. And so the PC player is able to offer that advice, but only based on the color of the reactor, which the PC player does not see. So they do rely on those who are in the shared environment to be able to share that. So there's a bi-directional interdependency created between both players. Another preliminary finding was that interaction and locomotion mechanics that leverage the device's abilities and support the narrative had a positive effect on the player experience. So here's a quick video just showing the AR player that they're not just kind of tapping on a tablet, they're actually moving around. And as they move around and rotate, their avatar who is in the VR experience, that movement that the person in the physical world makes, whether it's moving or rotating, is represented one-to-one with their AR avatar. So it's able to leverage those devices and draw them into the experience. Anthropomorphic avatars for all players will improve social presence. So again, going back to this example, one of the things I found that the PC player who I tried to take a different way to have them embodied in that experience actually got overlooked and forgotten quite a bit because the VR and AR players didn't really perceive that security camera as a person there, even though they could hear them. And so really looking at how can we represent the different kind of players across these cross realities, and really having avatars that are humanoid in nature are really a key piece there. And again, with the AR player, this is the view of the AR player. And so they just are looking at a window into the virtual world. They don't see, in virtual reality, we often see our hands and maybe our torso that help embody our embodiment. The AR player didn't have any of that. And so they felt a little disconnected even from their own player within the experience. And then the last key finding was that narrative and role had a positive effect on the player experience, motivation, and engagement. So going back to the PC player, even though they're not in an immersive device like a virtual reality headset, because of the role that they had, the narrative that they were given, the limitations of a computer actually worked to their favor because it made sense with the narrative, it made sense with their role, and it actually drew them into the experience even more. So some of the discussions, I'm looking at non-VR players can have a similar engaging experience as VR players. A primary factor affecting player experiences, narrative, and roles, specifically roles that leverage the device limitations, which can shift the paradigm from being a limitation to a natural interaction. Through interdependencies, shared interactions, and team communications, players felt social presence despite being physically separated. They were in different rooms, even though that was the case, they felt that they were connected. So some of the next steps, is to complete my thematic analysis and then create a best practices guide based on my research that's going to be informed by some of the other literature that I shared earlier on. So I'm not sure what I am for time here, but I think that's the end of my slide deck.
Perfect. Thanks a lot, Mike. So a quick reminder again, write your questions in the chat, please, so we can have a discussion that is not just revolving around me rambling about things that I find interesting. So we're going to come to our next speaker, and it's going to be on the paper Flexible XR Prototyping, a sports spectating example. And the presenter is going to be Wei Hong Lo.
Yeah.
Hi,
can you see my screen?
Yes, we can see your screen. We can hear you.
Okay, let me just minimize you guys. All right. Okay, cool. So I'm going to start. So my name is Wei Hong, and I'm from University of Otago in New Zealand. And I'm going to present Flexible XR Prototyping, which is a sports spectating example. So a bit contrary to what was mentioned about cross reality, mine is actually different prototypes in the Milgram continuum. So basically, I developed 4 different prototypes rather than one prototype that goes cross reality. But anyway, I think it still could be applicable for cross reality prototyping. Let me go next. Yeah, so just to introduce a bit on my research. So my research is called AR Spectator, which is actually a research project using XR approach that integrates event-related information into the on-site spectator's field of view. So what this means is we want to put broadcast visualizations into your AR field of view when you're on-site in the game. And this could be done either through mobile or AR head-mounted display. So the 3 main reasons why we are doing this project is because if you go to a stadium, there is no commentary. So there's no one explaining what is happening in the game. And then you do not have visual aid as well, like you get on television, where you get to see all your fancy visuals and statistics. And then you have also no proper view, in a sense that depending on where you're seated, that is what you get to see throughout the whole game. So if the action is happening on the other side of the field, you don't really kind of get your cameraman to show you what is happening. So with this, we created something called AR Spectator, which is my PhD project for the past 3 years. And this is a very early indirect AR prototype. So indirect AR meaning that what you see is actually just a picture, and then we just put content onto it rather than being an actual AR prototype. But so what has it got to do with cross-reality prototyping? So we didn't really plan to have many prototypes, but throughout the period of my PhD, we actually developed 4 prototypes over the span of 4 years, mostly due to logistical issues and the pandemic. So basically, we have issues accessing the stadium because this is a stadium project. And throughout the years in 2019, we developed an AR prototype and a lab AR prototype, which I will explain all the prototypes later. And then in 2020, a mobile indirect AR prototype. And lastly, on 2021, we have our VR prototype. So just to show, I think the video should play. So this is the stadium AR prototype, which is what we use on site. So this is actual AR where you see through it's a video see-through AR, but it is basically showing what's happening on the field. And then you basically see it through either your mobile phone or your AR head-mounted display. And then it has tracking and localization as well as the actual scale of the stadium. And then next up, we got miniature AR, which is also what I call lab AR prototype, where it uses an image target tracking to give you a bird's eye view of the stadium. So it's something like a God's mode of the stadium, and you could see visualization from different angles. And yeah, this one is quite useful for evaluation, especially from the developer's point of view, where you want to see, oh, how would this look from this angle and that angle? And as well, this one is 1 to 100 scale. So it's basically a shrunk version of the stadium. Then next on, we have the mobile indirect AR. So we started this with a 360 image, which then evolved into a 360 video of an actual game. So as you can see, I'm in my lab, but through the phone, it simulates as if I am in the actual game holding a mobile phone looking around. Yeah, and then again, you can see visualizations like you see on TV. And then this leads to the next prototype, which is very similar, but in a VR headset. And for this particular use case, I was looking a bit on context aware as well, but that was not the scope of this talk. So this one is done in a VR head-mounted display, where we want to simulate using the AR head-mounted display in the stadium itself. Yeah, so all the 4 prototypes are used for some sort of study. And yeah, so this is just a summary of all the 4 prototypes. So for 2 of them, you actually could see the actual environment, and 2 of them is more of a video simulation. And then basically all of them offers assisted viewing and use different tracking methods. So the main thing that came out of all these 4 prototypes are actually the flexible XR prototyping framework. So this actually came after the development of, actually not after, it's more like during the development of the prototypes. And what we found out is, first we need to design with purpose, in the sense that, do we need the different prototypes based off the locality, which is where are we going to use the prototypes, the scale, like, do we need a large scale prototype, or do we just need a smaller version where we could carry around, as well as evaluations, like if we are going to do evaluations remotely, do we need different type of prototypes? And once we decided what we want to do with the prototypes, basically we will have the different characteristics of a prototyping framework. So we have a modular design so that each of the prototype could also kind of have similar stuff. Let's say if you change something on prototype A, let's say the AR prototype, and then it would also affect the indirect AR prototype, or as well as the VR prototypes. And then it also need to have dynamic instantiation. So this one means that things are kind of instantiated by script rather than dragging through the Unity editor. So this is all done in Unity. And then lastly, a global coordinate for all the prototypes so that you don't get mixed up with different coordinates for different prototypes. And then with the model design, basically each of the prototype will have a tracking manager, a visualization manager, as well as a data manager. So the tracking manager would be identifying where you are in the stadium, as well as tracking where are the players. And then the visualization manager will determine what to show you, either through context awareness or just manual match operator. And then the data manager is where all the data sources comes, usually from our sports statistic provider. So yeah, actually, it's a pretty simple paper, but basically what we did was we did 4 different prototypes. And then from that, we kind of understand, yeah, the different prototypes, the way we done the prototypes should be done in a better way. So we developed the flexible XR prototyping framework. And what I'm doing now is basically trying to reorganize all the prototypes into what I propose in the framework, because currently, if I make changes in one, it doesn't affect the other prototypes, and that's causing quite a lot of hiccups in the development process. So yeah, now I'm in the phase of reorganizing the whole project based on the flexible XR framework. Yeah, so I think that's kind of about it. This content is also published in the IVCNZ paper last year. And this workshop paper is kind of like a short version of it. So I think, yeah, that's all from me. Thank you.
Thanks a lot, Wei. So we're transitioning now to the discussion phase. Uwe gave us, we have 10 to 15 minutes to have a discussion before we go to the coffee break. So I see already that in the Miro, we have some questions piling up for the participants. Also, I saw a little bit in Zoom, so I will start. Please, all the presenters that we have, please unmute yourself. And I will go through the questions first that are presented here in Miro. And I think the first one is for you, Michael. And the first question is, there's no name on it, but it goes, do you have plans to design a game that would make players' role rather symmetric? And also I had a similar thought that I saw that you divided the individual techniques based on the roles that you created. So is there a way to actually have different techniques but have the same roles?
Yeah, it's a good question. And it's one that I kind of struggled with as I was working on this project. And I think one of the things that I was deliberate with was that I looked at the limitations of each device or affordances and looked at how those could play to the role. So for example, with the PC player, they're fairly less immersive than a VR or AR player, but I played to that to the strength with the role that they had. So you could, I think you could move it along that spectrum there, but the way that they are engaged may be affected because of the limitation that those devices have. So it was one that I struggled with, but I think I was deliberate in picking roles that worked with how those devices could interact in that environment.
Thanks. So I don't know who asked the question, if there's a follow-up. Oh, Maglet. I see Maglet ask the questions. You can have a follow-up, or you can maybe add something. Yes.
All right, perfect. I'm not sure if it's too loud because I'm at the conference, so sorry, but first, okay, perfect. Okay, first, thank you, of course, for your insights on the presentation, Mike. But what I think is very interesting, that's why I asked the question, is like you mentioned the game Skyrim and how when you move the game from first-person shooter or third-person, sorry, they had like first-person or third-person in the game, and when you moved it to VR, then the UI didn't work properly, and then you had to readjust all of them. And currently many games are transitioning from different devices. So many games are coming from PC or PlayStation or consoles into smartphones, and some allow crossplay. So some allow people from mobile to play with people from PC and so on and so forth. However, they do this thing where they try to help players overcome the devices, the disadvantages that are from the devices. So, for example, people that play with a controller get auto aim, for example, than people that play with mouse and a keyboard. Maybe exploring this aspect specifically. I think the AR user is the most disadvantaged one, right? Because they have like a tiny screen. They also see the world from a very tiny screen. But I think it's super interesting to maybe explore how can you allow them all to have equal experience with an equal role and equal level of involvement and immersion with regardless of the type of device that they are using.
No, I think you're right, and that could be something for some future work for sure.
So it feels something that would be interesting if you actually have a competitive environment, right? If you actually have always the same role, as you mentioned, Hassan, if you play a shooter on a whatever, in a smartphone or a controller or a PC, you have these differences here, and then it's going to be interesting if you're able to kind of lift them all on the same level with the different devices, and if this is a goal. And that kind of brings me to the next question. Jonas had it. How can you expand the approach that you had to different settings or narratives? Is there a common approach that can help others to design such a connecting experience in all kinds of environments? So is maybe the common approach just lifting them all in the same, or actually staying in this asymmetry? I don't know. Maybe Jonas, you can elaborate. I try to present your questions in a good way.
Yeah, I think you did it right.
Yeah, and I think that's the ultimate goal is being able to present a set of best practices or recommendations for how to approach a cross-reality game experience. So I took a particular narrative and scenario, but then extrapolating out some of the findings and what would be things to consider when developing those experiences, whether it's a complete different experience, but what are some of the commonalities? And so I haven't quite gotten to that point yet in my master's research, but that's the ultimate goal for sure.
So I want to include Christoph maybe in this discussion. Christoph, I can see you. Oh yeah, there, you just lead back. For the work that you presented, you talked about this concept of visual coherence, right, in cross reality. And throughout the talk, I was wondering, is there any, how can I say, any like metric that you can apply where you can see that visual coherence would improve cross reality in terms of presence, immersion, performance, whatever it is? And like, is there something? How do you evaluate this benefit of having this visual coherence in cross reality application instead of having this odd artificial cut?
I guess that will be actually a pretty interesting research topic. So we're thinking about that. So in this work, we just presented some ideas where we think it could be useful, but we haven't investigated it in depth. But I think it's definitely worth looking into it because it's going to make a change if you have a different lighting and you transition between the worlds and lighting situation changes. I mean, that might be irritating in a normal context, but if you think about visualizations, you might have a completely different appearance on the data set. So you got to get it somehow coherent. And that's, in my opinion, pretty important. But I'm not aware of any metric yet. Yeah.
I have a simple gut feeling that when you argued about it, it's something that I see a lot of research around portals or around some form of, I don't know, showing the real world and the virtual world, and you kind of have this argument that there must be this visual coherence to that, and I kind of agree. I feel that I just try to kind of have some form of like strong argument saying like, oh yeah, we found that if you apply visual coherence, you end up with better orientation later on, better I don't know, understanding, better like plausibility in some degree.
We didn't look into in depth into that so far, but we're planning to do so. Because we think it's going to bring a benefit, definitely.
Yeah.
And
yeah,
I mean,
I agree.
You can also use the data just to implement different things like different transition techniques or so, which you get from depth sensing or lighting estimation, things like that.
Yeah. And you also had this point of immersive analytics in your submission, and I was wondering, is there maybe a specific thing? Do you know that maybe think that immersive analytics could benefit from this visual coherence? Is there any like an angle for such performance metric or being able? So, or even what scenarios would you say that for what type of data would you have immersive analytics? will or could coherence bring an advantage compared to traditional immersive or cross-reality immersive analytics versus immersive analytics?
So you mean in general or specifically to visual coherence?
Into visual coherence.
Yeah, so I think it could benefit, for example, I mean, as I mentioned previously, if you have a data set and you get different lighting situations on it, that's going to change how you perceive the data. What you ideally would want to do is, let's say you get a cross tabulation or something like that displayed in 3D as an augmentation, and you adapt the lighting of the real of the virtual data set to the real environment. And maybe if you combine it with, for example, data physicalizations or things like that, you want to have that also in coherent way. And if you move into VR, then you don't want to have a change of lighting situation or something like that. So it's got to be consistent, because otherwise you might interpret it differently.
Yeah, I think that's an interesting angle to have it in analytics, and maybe even go into performance and interpretation, as you mentioned. So when I think about this visual coherence, it reminds me of the work that Wei Hong presented, in particular the mobile indirect AR. Wei Hong, you had it running on a phone, right?
Yeah.
And I was thinking, like, if you would do this in AR on an HMD, right, you would just embed this scene, not in full VR, because you had this component as well, but in AR. Then, I mean, visual coherence would actually make sense as well, right? Because how do you embed this part of the stadium in this augmented world that it's kind of realistic coherent? So have you thought about what would change if you just port this mobile version that you had on a mobile phone to an AR headset without going full AR, full VR? So do you see there is an advantage or something interesting there?
It is possible, but like because of the field of view of the AR headsets, it would look a bit weird. Like it's possible to embed certain parts, but because you will definitely see parts that are kind of fishy, and then parts that are truly AR, like I mean truly see-through. So I would think that there will be more issues with visual coherence actually.
Because of this clash here between. So we had one more question, and I think Mark posted to Michael, but I'm curious about all three of you, right? Because we're in this workshop on prototyping, and you all presented to some degree systems and implementations that you had. And maybe we can start with you, Wei Hong, to ask how did you actually prototype that? How did you prototype your application? What pipeline, what tool did you use?
Yeah, so I used Unity, and then I think the first prototype came out at the end of the first year of my PhD. And then the rest came out pretty much in a couple of months, like after another. And it's quite easy to, I mean, it's not say easy, but it's relatively faster afterwards because it's all using the same basis. But and all the prototypes are actually still simultaneously maintained. Like if I add stuff to something, I'll add it to the rest as well. But that is where I realized that if we didn't have a flexible XR prototyping framework, you got to do all the changes manually, and it kind of get pretty much like a terrible Git branches, and then you can't just merge it together because it's just all kind of different but same. So I think that's why it's important to plan it in advance and kind of modularize it and try to reuse the same components to basically draft all the different prototypes. So even if you are making cross-reality prototype that means just one prototype, make sure that everything is kind of modularized.
But this means you started right away with Unity, right? You did not have a phase where you had like paper prototypes or some form of really early explorations. The first version, Jack, we actually started with Unity.
That would be the first interactive version. I did have some sketches, but it wasn't like evaluated with users in that sense, like what was mentioned by Herman.
So maybe Mike, could you comment on your process? How did you prototype the system? What was your steps?
Sure. I did some sketches similar to Wei Hong. I used Miro for some of the sketches for as far as the interface goes. But then went right into Unity to do the prototyping. And the way that I built the application, even though it was for 3 separate devices, I used one scene. So they had a shared environment and then device detection, so that when I had to make changes, I just had to change the application once and then rebuild it. I didn't have to change it in all these different places. So I agree with what Wei Hong said about having the shared components, especially when you're dealing with cross reality devices. And that came in handy. So before I did the actual research, as I showed on the screen, I did do some user testing with some individuals, and actually version 1 looked different than version 2, both from the interfaces, but also the layout. And it was a lot easier to change because it was one project and then one build. And actually for the AR and the Quest, it was the same build file because they both are APK, so that was even easier.
And Christoph, maybe your comments on your pipeline when you implemented the systems?
So we're typically going with early sketches to get an idea, and then we'll go directly into Unity. So that's pretty much our approach.
Yeah, so it's all kind of similar across all the applications. It's also a nice segue to the demo session that we're going to have later. We'll be presenting a tool that we hope can actually help and support this type of prototyping early on. So thanks. Let's thank all of our presenters again. Thanks a lot. I think we're right at the time slot that Uwe gave us for the discussion. We can go to the coffee break. And I'm going to give over to you, Uwe.
Yeah, the unofficial one that I gave, like to extend it a little bit longer and not like stop the discussion in the middle of it. Thank you all. That was very interesting. Very nice presentations. I would say we make like a 15 minutes break now. And that means we're back here at 50, so 10 before. I try to avoid to say the hour because I guess that's different for everyone. So we're back at this time, and then we'll continue with the demo session. So enjoy your coffee break, everyone. Yeah, welcome back, everyone. We will continue now with the next part of the program. So before we have the second paper session and also the closing keynote, we have a little bit more interactive part in the middle now, where we're hoping that we could, for one, like allow people to try out a prototyping tool in VR, while kind of streaming it here for all those of you that don't have access to a VR device at the moment. And thereafter, we will have a very short group discussion, a little brainstorming. We kind of want to gather some opportunities and challenges of cross-reality prototyping and potentially form some collaborations or like also maybe like paper ideas in that direction. So let me share my screen. So, all right. So for the demo session, as I mentioned before, I at least sent the email around to all the authors. I'm not sure, like people who joined on the spot here probably didn't receive that. So I will share the links also in the chat again. I sent around like the APK for this. So like what we're going to show is the VRception system. It's a toolkit that we developed, was a paper at CHI this year that we received an honorable mention for, where the idea is basically to simulate the entire reality virtuality continuum inside of virtual reality, and thereby to allow it more easily to prototype cross-reality systems. So I have a short video clip here. Let me see if I shared. No, I didn't share sound, and I didn't optimize for video clip. So I tried again. I hope you can still see the slide deck. So let's start.
We present VRception, a concept and toolkit for quick and easy prototyping of cross-reality systems. By simulating all levels of the reality-virtuality continuum entirely in virtual reality, our concept overcomes the asymmetry of realities. Based on our concept, we developed the VRception Toolkit, a multi-user toolkit for quickly and easily prototyping cross-reality systems.
All right, so let me, before we share this, so hopefully you saw this a little bit. Sorry, there were like some boxes on top, like the Zoom thing was jumping around, but I hopefully think you got the idea. So first question would be, so initially we plan to have breakout sessions, but apparently they're not enabled in the Zoom, and I contacted the people responsible, but I didn't get a reply so far. So let's hope that that is figured out, at least for the brainstorming session after. So first of all, I would like to know who here has a Quest device and is able to try out the demo themselves. Maybe raise your hand. All right. So, all right, we have 2 people who are actually in possession of a Quest. So I assume the others are not. So it will be as follows. If you like join the VRception toolkit, it's a multi-user application. So you will all be put into one room where you can use the voice chat. We limited it to 4 people at max to kind of make sure that yeah, people can talk and try it out and have not like it's super crowded and laggy. So therefore, like always 4 people would join in a room. Can I ask the 2 people that raised their hand, did you like already install VRception, or do you like still need to do that now? So I saw Mike did it already, right?
Yeah.
Have it installed. Okay, one is downloading. So yeah, I will kind of try to share it here as well. Let me see how well that works. So I will directly share from Unity. So I will have the Unity client connected as well. Let me see if I can share this here. Hope you can see this now. Let me see if I can quickly help our player to give you like a better view of the room. So if you want, you can already join. So let's see if that works out. Unfortunately, can't see people's faces anymore, but I assume you didn't leave. So I will also try to join, make sure that like, so in the application, if you start it, the voice chat will be disabled. So like your microphone will be disabled, but if you kind of double press the B button, also the upper button on the right controller, there's one person, then you should also be able to speak. Just make sure that you're like muted in Zoom, because otherwise I think we will have hear you like several times. Let's see if I can also join. All right. So I will make sure that my microphone is deactivated. Hear me twice. So The interesting part now is you can kind of, if you have your, on your left controller, when you press the X button, you get like a menu of different items that you can basically drop into the scene. As you can see here, you can use this like projector, for example, and place this in the scene, or I can use like a display here. So the interesting thing is you have like on your left controller, let me quickly, there is a an option so that you can kind of control what you're currently seeing. So in the beginning, you see reality, but if you, for example, move that slider over, you can see that you're like slowly fading into virtual reality, and kind of like can jump to positions in between, like an AR view, for example, where there's a little bit of virtuality and reality still visible, or like the other way around, where it's augmented virtuality, where the reality gets faded in. So, and as you are in this simulation, you have like different tools available that you can use, like there are different components with which you can prototype. So I showed here like the display component and the projector component. And yeah, so the trick of these display and projector components is they kind of, when you spawn them in reality, like I did here on the screen, then they show virtuality. And if you spawn them in virtuality, they show reality. So they inherently like bridge between the two systems. Yeah. So how is the status? Like, are there more people trying to join? So I heard that Jaman is like trying to join. How's it going for you? Are you done installing, or what's your status? All right. Yeah, it takes a moment. So yeah, as you can see, the idea is like also that we have kind of not just the VR environment itself only, but also kind of the Unity component. So as you can see here, we have like a very straightforward setup where you can kind of configure like the VRception toolkit. You could add like new prefabs and things that you want to prototype with. So for example, if you want a depth camera or something, you could implement this and then provide it as a prefab here. You can simulate different spaces. So we call this here left space and right space, but in fact, you could like not just transition between reality and virtuality, but you could also transition between two virtualities if you wanted to prototype for in between VR experiences. As you can see, you can just load existing scenes. So I have like different scenes for reality and virtuality here. And you could like just load your existing Unity scenes and specify them as this is my reality, this is my virtuality. Yeah, we have different experiences, as you can see, like these little cameras here that you can find over like here, for example. These are like quick jump to points where you can specify like a specific reality. So if you like prototype a certain experience, you can easily jump back into like these perspectives to like look at it from like a AR or VR perspective. As you can see also, like depending on what you currently view, so you can see, for example, that Mike at the moment is like in VR based on his headset, but if you kind of like move, look at like my head here, if you kind of like move through the experiences, then you can see that like the headset is changing. So I think like if Mike is able to jump to AR, we would be able to like see this on his head. Oh, we got there. So you could see like now he's in reality. So you see like there's nothing on his head, but if he moves like a little bit over to augmented reality, then there should be like the HoloLens coming up, depending on like where he currently is. So like now again, like a VR perspective. Let's hope there's no bug at play here at the moment. Oh, there's the HoloLens, the AR perspective. Yeah, you have a network feature. So like, as you can say, you can specify, make sure that you enter like a room that you want to use. For example, you can have as many players as you want. There's a storage system, so you can like log your complete experience and then replay it, like to see what happened in the prototyping process. And yeah, I think that is mainly it. Yeah, are there any questions from the audience on this experience? Maybe some insights from Mike on like if you enjoyed that experience. Or we still lost him to VR.
Well, I just have to say, I think this is actually amazing. So I teach virtual and augmented reality development to college students, and this could be an amazing tool for them to visualize and prototype experiences before they go to a whole build. So I think in one of the emails you did provide, like we can download it, and you gave us a link to like the GitHub repo, I think. I think this is a really really cool tool.
Thank you so much. So if you, I can quickly maybe share this also here. So this is the GitHub that we were talking about. So you can simply download the project, try it out in Unity yourself. Also, you have the APK now. Try it if you want. We were kind of sure that it would not be everyone having a Quest available on the go. Yeah, was it so Matt, I thought that you were like watching. Was it was it visible for you? Like, do you like see actually what's going on a little bit in VR, or do you have the feeling you're a little bit left out here?
Yeah, I didn't bring a headset to Singapore. But yeah, no, I could tell what was going on. And I had played around with it a little bit before, but I think I just got as far as like the Unity editor for what I was doing before. So it was cool to see it in action. Yeah. Yeah. Right. I think I'm particularly interested in transition stuff. So like the slider to go between I think is a nice feature and one that I might play around with. Yeah.
Thank you. There was a hand raised. Maybe we start with Hassan.
Thank you. I haven't tried it yet, but I'm really intrigued to try it. And I have a question. Did you consider introducing smartphone AR into this as well? So not just the HoloLens, so having as well a user and using a smartphone or a tablet in the environment?
Yeah, I think that's a very interesting idea. So like so far we were focusing on is so you can build in a lot of support for different VR headsets for different devices, but we kind of like started to explore this idea by implementing it for the Quest only, because it's a kind of like, yeah, most sold consumer VR device. It's standalone, so it's kind of like easy to try this out. But with the networking feature and Unity as a platform independent software, it should be possible to kind of also transport it over to the smartphone. It just comes with probably a little bit more of additional workload. So like we had this one feature, for example, where you could like scan your environment, for example, like with an iPhone or something, and then bring it in as your real world environment to like kind of prototype with this, and then you could like synchronize it to your actual space, so that when you touch something in your real world in VR, then it's still like existing there. And I think for that, like smartphone is like a nice component where you can have co-located experiences where you can really like look into what the other person currently sees. I think it is less good from my perspective if you kind of are just solely by yourself at your smartphone and looking through this a little bit. So therefore there needs to be like some syncing mechanism as well to kind of integrate it. So we didn't check this out so far.
Can I have a follow-up suggestion?
Sure.
Maybe that I think it will be cool. So the whole idea of scanning the model, and then I think there is work already being done to stream scan 3D models across maybe a distributed now, so not co-located users, but rather distributed user. Yeah, and it would be interesting to use things like spatial anchors, for example, to kind of calibrate. So this is something that I've already used when I'm trying this distributed VR and smartphone AR users for a remote user and an on-site user. And spatial anchors worked really well, Microsoft's Azure spatial anchors worked really well in overlaying the virtual world into the real one, so that you can have someone at your home wearing a VR headset, and then you stream the 3D model. So I think this also would be super interesting to kind of not, because smartphone AR is being a little bit, pushed to the side, but I think it's the most accessible thing now, right? So
that's true. Yeah, the spatial anchors are definitely, I saw that. It's definitely something to try out. I think the only problem that we have a little bit is this kind of, if you prototype like with multiple users and they are all at different real world locations, then you need to provide different real world simulations, right? Or you can simulate one real world for all of them, but then it's only the real one for one of the people participating. So there are like some inherent challenges resulting from this, but the special anchor one will definitely give us a shot. Yeah, then there was another question. I don't know who came first, to be honest. I would just give it to Christoph, because he's not said anything so far. Give him.
Okay, thank you. Thank you very much for a really nice demonstration. So I basically got two small questions. So when you think about simulating devices, I mean, you're playing with a HoloLens metaphor. Are you also considering the field of view of the HoloLens? So if you see, let's say, augmentations in there, so are they restricted and limited, or are they at full scale?
So we did like different things. So like the slider that you saw for like this transitioning between like reality and virtuality, that was really like our first thing that we did, where we used like some alpha blending to kind of just blend those things together. This is absolutely correct that has it's not necessarily the real thing, right? Like, so if we would imagine this continuum and transitioning, it's not just transparency. So we implemented like different functions, so you can basically select what you want, how you want to transition. So there are like other functions where there are a few objects appearing at a time, and then like more and more come over, and it's not like a blending in the sense of like transparency, but the objects itself. But to the question yourself, we have implemented like an experience mode to kind of really get different manifestations right. And for that, we have like, for example, an AR experience that kind of limits the field of view, for example. So to kind of show only, so you can basically specify what type of device you want to simulate, HoloLens or Meta or whatever. And then you can specify, then it automatically kind of understands what the how much you would see in that experience. So like these things are there. I think we just started it to kind of like show how it would work and how somebody could like go on to implement it in full detail. But I think you find this in the project. Yeah.
Okay, thank you. Yeah, the other question was, but you answered it before, why you actually opted for Fade. And but you mentioned that I guess it's the most simple way to implement. I mean, I'm not sure if you're around in Singapore or if you participate online. We got a talk on Thursday on that, and we evaluated different transition techniques. And Fade doesn't perform too bad actually, so it was a good decision that way.
Yeah, but that's inspiring. So like we currently we work at like a new version of it where we kind of like try to fix a few things and improve them. And one of those is to kind of allow others to kind of prototype with it or build something with it and then share it with everyone. And I think that paper will be a good start to kind of like look into different transition techniques that could exist and kind of like have them in the tool, have them available, because I think that is very nice for people to actually, so I think this is a big step towards like more reproducible scientific results, where we do not necessarily have the full hardware system or the real-fledged implementation, but where we can kind of like hint at what is there. And especially like what Mike mentioned before with regard to education, I think it is very valuable to kind of to show it to students and to quickly try it out and to see it for yourself, how this works. And for this alpha blending, it just feels so nice because it's like the seamless thing, and like really like continuously something is happening. That was kind of why this was our like go-to main implementation. But as you pointed out, there are like many others that we could look into. Yeah. Thank you very much.
Okay. Thank you.
Then I would give it back to Matt, like to have the next question.
Sure. I'm wondering, is there plans with the project? 'Cause I know it was for Kai and for research. Is there plans with the project to expand the prototyping ability? So for example, with a little tablet that we were holding that we could bring in the display of the projector or some primitives, is there a plan to maybe bring in so that we can bring in Sketchfab assets or whatnot so we can actually prototype full experiences? Is that kind of in the roadmap for your project?
Yeah, so like we have like got a lot of feedback, and a lot of people tried this out, and also at Kai, and we like presented this as other conferences as well. And like you always have somebody who's like, this is the thing that you should do, right? Like as you, for example, now brought in like the tablet as one version to continue. We have heard the smartphone before. So like there's tons of directions you can take it from here. I think we did our part by trying to have the code open source and also putting in an effort to actually document it, because I think like many so this is kind of the next step, right? So we see people publishing their like GitHub repositories, but oftentimes if you want to really try it out, you feel like there's not much documentation around it to like explain. It's research after all. So we put in this effort to kind of allow people to extend it in these ways, and we hope that it inspires people to say like, for my research, it's more important to have like the haptic sensation of the prototyping, for example. Therefore I bring like a tablet surface in where I could like prototype against, and thereby kind of making the tool more useful and contributing to it. So I mean, yeah, that sounds like a not super good answer, but go ahead if you kind of have a good idea for how to improve it and contribute to the project. You're very welcome to do so. All right, then there's a question from Matt.
Oh, sorry. Yes, I have two questions, and then they're both kind of feature questions. Can you set a slider? Can you set a reality virtuality slider on a per object basis? Like, can I have an object that I put in the virtual, or I maybe I'm having trouble visualizing exactly what I mean, but can I like move an object from real to virtual or something? I guess this is kind of getting like ultimate display, but do you see what I'm saying? Can I move the object but not necessarily my full view? That's my question.
Yeah, I understand your question, and I think this is also related to the presentation and the paper you're presenting, or like will be presented later, I think, in the second session. There's something coming in this direction, I thought, right? Like where you transition objects.
Yeah.
But to answer the question, like in VRception at the moment, yeah, you can either like use the slider to select a function to transition over all objects that are there. And as I said, there's this experience mode where you could like specify certain configurations. There you could like implement several experiences that kind of like show the different phases of like moving an object from one to the other. But at the moment, there is no direct support of like selecting a certain object and transitioning it over. That doesn't exist at the moment. I'm sorry, but like okay, I think it's another very interesting idea to kind of continue with this. Yeah.
Sure. Yeah, and I understand your your position as like everyone has all these ideas. So yeah, I'm asking these as a potential contributor, not as I'm not trying to be like, make sure you add this to your list. But and that being said, another question related to feature sets. Can you use the pass-through API for Quest?
Yeah, you can. We have so there's currently like an early alpha version, but it's not stable yet. So simply because we were like, oh, we could add this and this and this, and then we tried to add this all at once, and now we're a little bit stuck in development of it. But there will be like a version that comes with the pass-through API. It's just like one of the issues that I mentioned before. So if you prototype like a multi-user experience that is co-located, but the people prototyping it are not actually co-located, then that is possible by kind of integrating one scan of a real world environment and everyone sees the same real world, right? If it comes to like the pass-through, you actually show what is around you, and there's no way of sharing this. So like Meta makes it very safe or sure that nobody gets this camera feed. That is just like injected afterwards in the SDK. So therefore you could never show what you're seeing. So like a prototyping with this pass-through API in a multiplayer or a multi-user version would always end up in everyone seeing their own reality. So, and then the question is a little bit like kind of, do you treat this as like different places, or like do you allow everyone to kind of inject into this reality? So there's some fundamental questions of like how you would go on about this. But I can say so much. In the next version we will support like the pass-through API, and we'll see what people will do with it and how they use it. The version how we currently planned it is that then it becomes like individual. So then like if you prototype something in your reality, it's not visible to somebody else but you, because like only you see your environment. But that could be like a limitation, of course. Yeah,
sure. Gotcha, thanks.
Perfect. Are there any more questions to the prototype? That seems to not be the case. All right, then we have let me quickly try to share again. So then I would say we come to the next part, which is an interactive part. So we wanted to give the chance to everyone to kind of get to know each other a little bit, and yeah, to not at the end have the feeling that you joined a workshop, saw some interesting presentations, but did not really make any contacts, or did not really get to know like the people involved. So originally we had it planned as there will be like breakout rooms, but yeah, there is some technical issues. So like in the beginning we had the wrong Zoom link for the wrong day, as there are multiple virtual room ones, as I said before. Now we figured that there is no breakout rooms available, even though we asked for it. And like I also tried to contact them in the beginning, but they didn't reply to me yet. So we probably, unfortunately, don't have these breakout rooms available. So therefore, we can only work as one large group. That changes the plan a little bit, but I think we can do it nonetheless. So the idea would be that we kind of, in the beginning, do a little get to know the attendees. So everyone has like a short time who's willing to participate here in the interactive part to quickly introduce themselves, to say where they're from, or like from which university affiliation, what is interesting to them about the workshop, so why they joined. And then thereafter, we want to do like a little brainstorming to in the mirror board to basically collect some opportunities on one side of cross-reality prototyping, and some challenges on the other side. So very top level kind of overview of current opportunities and challenges that we are facing. And based on these, we would then have an open discussion where the idea is to think of what could be potential future research contributions. So things that we could do in the past to kind of make use of an opportunity or to tackle a challenge that is currently existing in research. Yeah, that's also meant as a way to kind of form collaboration. So it would be like very cool if we maybe like identify people that are interested in that, and then we can set this up as a potential future collaboration. Yeah, as we are working in one group in total, there would also not be this part of think of the gained insights to share with everyone and then presenting it to everyone. So we leave that part out, and we just stick with like working in one big group on this. Cool. So I have a Miro board planned. I hope you all have access. I shared this with you, but I will quickly get the link again and post it here. So for those of you who did not have access yet, here is the Miro board link, and I will try to moderate this a little bit. So yeah, maybe we start with the short introduction round. And I see that there are so many people in an interactive session that I have not anticipated, but let's see how we get through this. So yeah, I think the organizers said who they are, and I think the keynote speaker, we also know already who he is. So that's why I would say we jump to the individual saying hi, and maybe we start with the lab that we have today joining us from Christoph Antes. Maybe you can quickly say hi.
Yeah, hello. So as you can see, I'm not alone here, so I got my research group with me. So my name is Christoph Antes, University of Applied Science Upper Austria, and my background is mainly in virtual reality. So I started there ago with my master thesis something like 20 years ago from now, and I'm still in the field, so switched over to doing a bit of augmented reality. And currently we are working on a 5-year project dealing with cross-reality topics, and some of the areas we talked about already with transitions, but also visual coherence, and there are many other aspects which we are looking at. Yeah, so I mean, do you want an introduction session for the group as well, or I mean,
if we can hear them through the microphone, why not? Like quickly say hi.
So.
Hi, my name is Daniel Schweider. I work as a researcher at the Hive Research Group of Christoph Antes, and my current research focus is how to move graph data visualizations along the reality-virtuality continuum, in particular from large-scale displays to augmented reality 3D space.
Mm-hmm.
Hi, my name is Christian Stach. I joined also the research group. My main topic is the co-located collaborative work for my master thesis. Thanks.
Okay. Hi, I'm Janine. I'm working on touch and spatial input in augmented reality using a handheld tablet. So, yeah, thanks for letting us join.
Hi, I'm Bernhard Bröller. I'm actually with a different research group, also at the University of Applied Sciences here, and working in the same project as Christoph was explaining. So, and we are working with computer tomography and visualizing that in virtual and augmented reality.
Mm-hmm. My name is Judith Friedl. I'm also obviously a member of Christoph's research group, and my focus in the group is on the evaluation of those cross-virtuality transitions.
Mm-hmm. And the other half of our group is in Singapore. No, just one person.
All right. Perfect. Thank you so much. Then I would continue with Matt. Would you like to say a few words?
Sure. My name is Matt. I am a third-year PhD student at the University of Central Florida. I've done some research on bystander interruption of VR users. So I've looked at that problem from the VR users perspective, which I presented at ISMAR last year. And this year, if you want to stop by my poster, you can see a prototype that I am using to explore that VR interruption problem from the interrupter's perspective.
Thank you very much. So then, Mike, I mean, you said already who you are, but maybe you can.
Sure, thanks you. Mike McCready. I am an instructor at Lethbridge College in Alberta, Canada, and also lead our Spatial Technologies Research Center that we started. And I'm also currently a master's student at the University of Kent, studying what I presented, enhancing player experiences in asymmetric VR gameplay.
All right. Then I saw that Michael has joined. So maybe he kind of, I think, is one of the last organizers to introduce himself. Say a few words.
Hello. Thanks, Uwe. Good morning / evening or wherever you are. Yeah, hi, I'm Michael. Currently professor at the University of Michigan and also on sabbatical at Meta Reality Labs Research in Redmond. I do HCI, AR, VR for a bit. My main interests are in the past have been in empowering non-technical designers to create AR, VR experiences. More recently, we've looked more into how to incorporate support for safe design in these tools. So we have a new range of tools hopefully coming out over the next few years. I say that because that will be true. Might be, or sooner than later, depends on reviewers. And that is focused on incorporating principles of security and privacy into interaction design tools. Yeah, I'm happy to join.
Thank you. So then Mohammed from the organizers already introduced himself, so I would give it to Mohammed from the audience to say a few words.
All right, hello. Yeah, my name is Mohammed. I go by Mo. I'm from Simon Fraser University. I'm working at immersive analytics, mostly immersive analytics in hybrid reality kind of situation scenario. I'm final year master's students, and yeah.
Thank you. There you have Rob Coles. Sorry.
Hi, yes. Hi, so I'm Rob. I'm from the KU Leuven in Belgium at the ARIA lab. Third year PhD student. I'm also focused on cross reality in my PhD and mostly worked on collaboration between VR and AR users up until now.
Mm-hmm. Thank you very much. El Hassan?
Hi, I'm El Hassan Maklet. So after my master thesis, I started working mostly in the industry, creating in Egypt, creating games and interactive AR and VR applications. Then a year ago, I went to academia. I'm currently a researcher and PhD student at Ilmenau University, Ilmenau University of Technology, to Ilmenau, and in the virtual worlds and the digital games research group. And yeah, I'm mostly interested in bringing the smartphone AR user into the cyberspace or the metaverse through cross-reality social or collaborative experiences, mostly focusing on user representation and user tracking.
Mm-hmm. Thank you very much. And then we have Wolfgang here as well. Maybe he wants to say a few words.
Yeah, hi, my name is Wolfgang Stötzlinger. I'm also at Simon Fraser. I'm Mo's supervisor at Simon Fraser University. I'm currently in Singapore, so that's why it's still a different kind of time zone. My interest is really also in the direction of how to bridge between dimensions and systems for immersive analytics.
Mm-hmm. Thank you very much. And then I see that Alberto is also already here, so maybe you can say hi as well.
Yeah, so welcome to everybody. I'm Alberto Simeone. I'm based in Belgium at the KU Leuven. I've been working across the whole spectrum from virtual reality to cross reality now, and I will close the workshop later on. So you'll see more about it from me in a couple of hours.
Mm-hmm. Thank you very much. So did I forget somebody who would like to say hi as well? So I skipped those that had the camera turned off because I assumed they might not be around or don't want to say something here. All right. Cool. Then we can start with the interactive part. So now in a larger group. So that's why I kind of would make it in a way that everyone has a moment for themselves to think about the question that we put out. So I hope everyone has access to the Miro board. And initially, as I said, we planned breakout rooms, but we don't have that available. So there's only the group 1 on the bottom left that I have enabled. There are some sticky notes around here at the bottom. And I would kind of ask you all to start with the first part. So we would like to think about potential opportunities for cross-reality systems and their prototyping. So I think I would give about like 5 minutes so that everyone can kind of think about it. Please write your idea or what you have in mind down on the sticky note. I hope that also for the lab that we have joining, that the Miro board got shared there, or that you kind of collect a little bit together. Awesome, perfect, that's a thumbs up. So I would say like 5 minutes now, so till 40 to kind of collect opportunities of cross-reality systems and prototyping that we have. All right, so who's still writing should come to an end. First of all, I would like to say thank you very much for being so interactive. I had a very big fear in the, so I've been workshop chairs a couple of times, tutorial chair as well. And whenever these online things were saying, let's do it interactive, let everyone like participate and put in their ideas, you could see this participant list like shrinking down and like everyone leaving and coming back to the non-interactive part. So I'm very happy that you're all here and contribute so well. So that's very nice. First of all, we have collected now a few opportunities, and I would like to ask if somebody is willing to share with us what they have thought of as a potential opportunity. Just raise your hand or directly start talking. Otherwise, I can help a little bit because I see this part here at the bottom as better cross-device communication protocols. It sounds almost a little bit in the direction of the metaverse. Who put that down and what was the idea here?
Yeah, I put that down. Yeah, the idea was from the pain that I suffered through when I was trying to connect multiple different things. So I had to create like WebSocket relays over here, and then some stuff in Unity, some other translation protocols, and again, other sites. But basically, there's a lack of standardization, I would say, for how you want to connect multiple different stages of alongside that virtuality reality continuum. Like, how would the different interactions would work? How would these different interactions translate into one another?
Mm-hmm. And you see like an opportunity here to kind of form a group of people that kind of thinks of like how such a protocol could be implemented, or like on a higher level, what does such a protocol need to convey? So would it be something like that kind of like tells, so this is an AR object, or this is like a VR object represented like this, or like which direction have you thought of here a little bit?
Yeah, I was thinking mostly about that. This was heavily inspired by the thing that Unity did in unifying all of the XR developments in the latest like XR development toolkit. Yeah, I was thinking more in line of that if there's a unified effort that we can put all of that language of transitioning between AR desktop or AR desktop VR into one thing that is agreeable by a lot of people, that would be desirable.
Mm-hmm. And I heard like Unity quite a lot. So I think like there were like in the talks before, people were also like, we do paper prototypes and then the next thing we do is Unity. That's why I'm kind of wondering, is there like people here that actually implement applications that are not developed in Unity? So is somebody like working with other software as well? And If so, do you combine it even? Like, are there even people here who might like work with Unity on one side, but then have the need for additional software as well? Something like this? Michael, like you?
Yep. I do a lot of WebXR, which is, I think, it's funny. I asked recently at Meta how popular it is in our research group, and people think Unity is so much easier than WebXR. It's actually quite ironic to me. But I think it's actually really good. And since Tuesday, since I Connect, we also have pass-through in the browser. It's just with an AR button. So it's a bit weird to, I mean, from the developer's perspective, it's just one of those things. They said we can just change one letter in a WebXR session, but from a design perspective, it actually makes a big difference. And now with the Quest Pro, whatever it's called, officially out, that's also fully supported, the color pass-through. And so I think it is actually a relatively powerful prototyping platform. Used to have some limitations compared to others, but I think WebXR is a very good alternative. I guess you talked about a lot of people do immersive authoring as well, but they're just previses of what could be, I think. So I think it's, for me, it's WebXR or Unity. I wonder how many people use Unreal Engine or what their experiences, if anybody uses it.
I saw Adalberto raising his hand, so maybe you can share a bit about your Unreal experience. Is it Unreal or is
yeah, well, I've used Unreal in the past, but more in VR now because of it's I think enhanced graphical capabilities. Like it's easier to make things look right in Unreal than it is with Unity due to its all different pipelines. It's a bit more complicated, I felt. And sometimes we don't need very advanced, programming implementations. So Unreal provides like blueprints, and so sometimes it's easier to get prototypes running. But Rob also, is in our group maybe has a fresher perspective on that.
So I've switched back and forth quite a bit now. So I especially like the multiplayer in Unreal Engine, especially since Unity has been. Well, I think now they have a new one, but was deprecated for a bit there. So I like their multiplayer support. On the AR side of things, I do think that the Microsoft tools are a lot less well supported on the Unreal Engine than they are in Unity. So Unity has got the better support going on multiple different from multiple different vendors, I think.
So you would say with your experience trying out both that people that currently work with Unity are not on the wrong track, or do you think there's like a change? So like for example, in artificial intelligence, we saw that people were using Keras quite frequently, and then PyTorch came along, and now everyone uses PyTorch. So is this something like similar in a way here, that I feel like that Unity is a little bit like dying in the sense of this of people like using it, and more people kind of trying out Unreal Engine, at least like from my personal experience, it feels a little bit like that, because people go for these like cool results that you can achieve that Alberto was talking about. From your personal experience, which one would you recommend? Like, would you say Unity has seen its time, or?
That's the standard answer. It depends on what you want to do, right? I always try to make a good judgment based on what the implementation requires. I guess.
And our use of Unreal stemmed, as it pertains to the VR side, is that because we wanted to design experiences that were located like in egocentric virtual environments, one where you are a person in a physical environment simulated in VR. So therefore, I felt, and since we have worked on that in the past, that the fidelity with which the graphical elements are rendered matters, in that kind of experience. So Unreal, you have tons of free assets available, so that maybe also makes the difference. Whereas when that doesn't matter, you see a lot of programmer graphics, solid primitives, and that's it. And also Unreal, I think, apart from research, I'm seeing a lot of use, because there are many. It's easier to be used by people who don't have a programming background, as I was saying. So, and I think perhaps that audience is bigger maybe than people who only know how to code.
All right. Yeah, I heard also from Michael, he said like he doubt that. So like, I think he's also still in favor of Unity, or?
No, I think, so it depends what you want to do is what people said. And I guess that's true, but I think it's more, it's not like whether you want to do AR or VR. I think it is, if your focus is on implementing interaction techniques, I think you more likely spend time in Unity. If it's on the visuals and creating like a really nice environment for your users, I think you're better off in Unreal Engine. That's the, at least that's how I think the mental model works with some of the XR developers that I know. I'm not sure whether it's
I also think from the cross-reality perspective that it's easier to make Unity do something that it wasn't designed for, whereas Unreal kind of locks you into the more game development workflow, kind of, because it's more specific towards accomplishing different things in game development. Like it's got a player pawn, whereas in Unity everything is a game object, for example. So it kind of more like it forces you to follow a good design practice more, which can also lock you out of doing things like more hacky things. That's also my experience.
Yeah, I saw also that Wolfgang like was not very agreeing, I guess. Like,
every tool has its purpose and it's what it's good for, and some tools are better than other things. Unreal in the beginning was it's gotten a lot better, let's call it that way, right? Right, and if you want to see what's going on in yards, Unreal is better, but again, it's not that one is substantially better than the other, right? It's a trade-off between the two, really.
Yeah, I think that's a very nice wrapping it up sentence to that topic. And I would like to kind of talk a bit more. There were like more notes. One that I found also interesting was one that said like, make it easier to debug XR applications using cross-reality support. So what type of debugging is meant here? Like what are the challenges? Already like skipping a little bit ahead, but yeah.
So I mean, when I wrote it, I was initially thinking more like from a complementary perspective, like you can use cross-reality support to debug an AR or VR application. So it's actually relatively interesting to bring a VR application into AR for debugging when you kind of establish a relationship to the real world. I wasn't thinking specifically of debugging cross-reality applications. I think that kind is actually more of a challenge, and I think I think actually both are interesting research ideas and something I've been thinking about for a while, but I've never actually really worked on. I also think cross-reality goes a lot in hand with multi-user, and I find that very interesting from a development and debugging perspective. And like we have several device emulators, and you could imagine using avatars and such things to simulate multiple users. And I remember when I was developing Kinect applications in the past, multi-user Kinect applications, one of my students found this really cool idea. They used like a stand and put a jacket on it, and then the Kinect thought that's another person, and so it detected a skeleton. And that was actually really funny to debug multi-user applications that way. We were so smart. And I think this is a very interesting direction for actually implementing cross-reality systems is tricky. I mean, it's more than responsive web design, which was just checking different sizes and making sure it looks kind of fine. Here, you need to actually test different kinds of interaction models and how things are displayed. If you do a very basic one where you can display a model in AR or in VR, then I think it's straightforward. But normally, the interactions will also have to adapt. And yeah, I find it very interesting.
Mm-hmm. Yeah, I think especially this aspect that you brought up with the multi-user aspect, that kind of, yeah, in the beginning we asked Mark what's the definition of a cross-reality system, and it focused around a little bit much about this multi-user aspect. I know that in the ESS workshop that happened, the definition that Adalberto and the others brought up was that people transition on the continuum, or that they experience multiple degrees of virtuality. Now it seems that more people are kind of focusing on this multi-user aspect for cross-reality systems. And I would be curious to hear from the others. So in the keynote in the morning, we had different challenges with regard to like prototyping and prototypes itself. And there we also thought like how we can make things easier and better, but like this multi-user aspect was never really captured, if I like remember it correctly, because it's also kind of, there were these prototypes where you prototype interactions and you need multiple users to prototype already the interaction for one user. So how does this scale with regard to like prototyping tools? Maybe, yeah, German, maybe you have an insight on this one. Like,
yeah, I read a question in Miro for the keynote that I didn't see before. I think the idea I'm hearing a lot, and it was in my head too, the idea of simulations of these edge cases, no? That idea that all these different problematic situations that you have, how to collect them, and then letting the tool to, you say test it when you have the user looking at the position that they need to look, or you have occlusion, or you have a problem with tracking, or we have all these big catalog of problems, and we need to test it again and again manually. We should have a catalog for that. That should be somewhere, and then we can automatize it. I'm not selling the whole AI thing, but I think the tool should help, not in everything. And I think when you have multiple users, I was seeing in the chat, like I was building these 3 applications myself, and you don't need to have like 5-person trying your thing in ideation. You could play along, and I think Michael was doing things like this. Now you record like user number 1, then you play it back, then you record user number 2, then you play back, and you put them together, and you see how they interact. So you can start faking these type of things in the beginning. Yes, the idea of simulated users, basically. But to which extent they are simulated or acted out, I think there is a decision there to make.
Yeah, we had like, if I add to this, like in VRception, for example, we integrated also like mannequins that you could simply like place in the scene, and then you could like take their arms and form them into a certain position. But it became quite obvious that yeah, you can jump into their perspective. So like changing between them was a nice mechanic, so that you kind of always like play the current role and then you switch back. But what we realized was that when you talk about these cross-reality systems, there's a lot of interactivity going, right? And the experience itself is like very dynamic. So to have like a mannequin, even in a pose that you can form, doesn't allow you to do like a lot. So we were quickly going to this kind of more collaborative approach where we make it easier to kind of remotely together work on this, like as a team of researchers where you try out things together. So that was kind of our take on this. But like I saw in the chat that Mike said something that they used normcore, is what he mentions here. So like maybe you can say a few words about like what you tried here.
I mean, that was just for the multi-user. I know someone earlier said how Unity's multi-user was deprecated, and then they brought a new version back. Normcore is just an SDK that allowed me to connect these different devices together. That still didn't solve the issue where, when I was doing the testing, I'd have my VR headset on, my tablet here, and the PC running, trying to go all three, because one of the challenges I had is because I built interdependencies, I needed to be able to interact with the players. So I'm trying to interact in VR and AR, and it didn't work very well. It was very painful.
Mm-hmm. But you were like in the end trying this out all by yourself, or did you had like at some point people like helping you, or that you asked like, hey, come here for a second, you need to help me?
So I did like, I guess like alpha testing all by myself, and then I did like kind of more final user testing with groups of people. But as I was developing it in real time, it was all by myself. And I think the idea of simulated users or ways to, recreate, whether it's like through AI or whatnot, the ability to interact with others without having to do it by yourself, I think would be a huge help for independent developers like myself.
Mm-hmm. All right. Yeah, then thank you very much. Is there like something else that we would like to discuss from the opportunity? So I see it's a little bit mixed. So I would say that some of the sticky notes already kind of mentioned challenges as they're kind of strongly connected. But my next thing would be that we kind of really take another 3-4 minutes quickly to kind of point out like some more challenges that we are facing. So like we have all, or like many of us here have developed or prototype cross-reality systems already and have faced like challenges. You heard already like a couple of opportunities in a way. So maybe we can gather some more like challenges and drawbacks, things that we would need to focus in the next time span, let's say like the next 5 years. What definitely needs to come? So what is the thing that we need in the next 5 years to make cross-reality systems and its prototyping more accessible, better? What are the main challenges that we face? So I would say like another 3-4 minutes to quickly gather this below the opportunities. I will create another frame and then I give some more time. All right, I see that some people are still actively contributing. That's very nice, but I would nevertheless slowly start the second discussion round around the challenges that we should tackle within the next 5 years. An interesting card that I saw was that said like allowing for prototyping to take place in virtual reality and augmented reality. I think that's a very nice point, as we've seen like many prototyping tools mostly like start with VR. Seldomly we see like papers that say, oh, here's the HoloLens, and with it we simulate VR. But nonetheless, those papers exist, and there's also a good reason to do that. So maybe who put up the point, and maybe want to say like a few words. Yeah, go ahead, please.
So I really think that one of the issues, for example, when I initially started designing for VR or AR, is that as I'm designing, I started using interactions that I'm mostly familiar with, like, oh, I'm gonna swipe, or I'm gonna scroll, or do like certain actions that were language based on, you know, flat screens. And later on, as I'm designing through a flat screen, I started realizing that I'm designing for a flat screen, right? Not for VR. And then like when I was working in the industry in Egypt, we started using tilt brush to design the space, like do wireframes for like, okay, so here we place this, here we put like a person, and we started designing these, doing these wireframes kind of in VR, and it helped us like design the experience very differently. And yeah, so I think if we're gonna do prototyping experience, then it should also cater for prototyping inside VR, because you're prototyping for a space that isn't 2D, so it doesn't make sense that you use a flat screen or a 2D screen to do that, to be honest.
There's a comment from Wolfgang.
Yeah, as somebody who has looked at the usability of side of VR, and you know, I started looking at this in the 90s when the usability was yeah, buckets per hour. Not from a cybersecness standpoint of view, but from an interaction standpoint of view. So clearly the 2D usability guidelines apply because they are deeply rooted in human capabilities and perception and so on. The one thing that is really different is, of course, the depth dimension, right? And I've been doing some research into how really this affects it. And you know, current best culprit is the divergence accommodation conflict that is basically inherent in all the stereo displays that we use. And you know, unless we get to multifocal stereo displays, we can't get around it. Still, your point of designing for 2D, yes, of course you do that, but there is also, because of divergence accommodation conflict, there's unfortunately, our visual perceptual system makes it easier to actually interact in 2D than in 3D. In other words, user interfaces where you have to do this, I'll use the camera here, right, all the time, are really bad from a usability standpoint of view, because they work directly against the visual system. So there's a little bit more to this, right, than you know, I wouldn't say that's necessarily bad, right?
Yeah, thank you for that's very nice input. I also there's another direction a little bit. This goes a little bit off, but it's as I mentioned before, like using AR as the tool to kind of prototype these experiences. I think there are like similar problems as the ones that Wolfgang just mentioned. But then again, there are also opportunities, right? There's a real world still, so there is some kind of opportunity to break out there a little bit. So I know that a few people here have used the HoloLens in particular, I think for like simulating also VR for cross reality or like XR systems. So maybe one of you can say a few words about like how that goes and if you would recommend to do so.
Well, I suppose you mean me. I'm not sure if anyone else tried that before.
I knew at least you had tried it. So
yeah. So basically, the HoloLens 2 has a good enough field of view and brightness that you can kind of do it, and just fill its field of view with VR content. And then if it's if the environment is not distracting, then people can get immersed in it. So it works, but it's not the ideal way to experience VR. So it's less immersive. But I imagine from a prototyping perspective, it would make it more easy to switch between contexts. I never like looked at it from this perspective, but it would make it more easy to switch between the development computer and the AR and the VR content in this case because of the see-through displays. So yes, that's a good idea, maybe.
But like, did you do something in particular, like to make this more successful? Like, just as a follow-up question, so did you like darken the room, or as you said, like uncluttered? Like, did you put stuff out to make it more simple to kind of create an environment where this actually works better? Or
well, not specifically. We do have a pretty neutral lab environment, which with like artificial light, and so it's not very bright by default. So.
Okay, maybe Wolfgang again.
Sorry, I don't want to hog this. Okay, so if I talk too much, just shut me up and don't let me speak. That's just fine with me. Okay, just putting that right up in front. Okay, we're using the Varjo, the XR3, and that actually makes it quite a bit of difference. Not cheap, I know, but luckily got a grant to finance that. And so with the Varjo, you can just turn off the video see-through, right, in software, and so, but also the resolution of the video see-through is high enough that you can actually read the monitor. So you can actually work on the real monitor. The only downside is that the headset is heavy. I'll say it that way. But you know, it was one of those headset setups. Sorry, that allows yourself to hang up. Sorry, I love the picture on Twitter. That was awesome. That makes it somewhat simpler, right? I mean, and but there's also new headsets coming out that now offer better resolution and better video see-through. So I'm quite hopeful there, right?
Yes, so we have a few people, or not a few, but at least like Michael here is like joining Meta for his sabbatical. And there's the Quest Pro 2. So I'm wondering, have you tried this? And like, do you know like if the resolution works for like reading a monitor in VR with the colored see-through?
I mean, I've played with the headset before it came out, but I haven't done tests like that, so I don't know.
All right.
Yeah, I cannot. I don't know actually. I haven't tried reading. I do think it's interesting. This. I mean, I think from a prototyping perspective, I really like what Rob was talking about. I mean, in a neutral environment, you could prototype the virtual environment using physical means, like decorate the lab. Or I think we can bring in other AR elements to simulate VR, like we could use projective AR. So I think it's actually quite interesting as a rapid prototyping. So I've always wanted to use, or we have used a little bit Room Alive as a way to prototype different kinds of physical environments quickly. I think that's actually still prototyping. What am I doing? AR? No, I got confused for a second. Anyway, this probably, I just thought through the projective AR, actually adding that into the mix is kind of interesting from a prototyping perspective. You can, if you will, prototype a virtual reality if you sufficiently augment around the user. I just think on a HoloLens, like the content, the virtual content would need to be very bright. Otherwise, you will not be able to compete with the physical world. And obviously, it only works in dark indoor settings. But I find the idea interesting. I wouldn't agree that the field of view is good enough to simulate virtual reality, but still, I like that idea. yeah, not much else to add other than I didn't do the Wolfgang test.
All right, so like maybe as a concluding question to this topic in a way, so do you expect that we in the future see more like prototyping tools that go beyond VR? So do you think that we will have people trying out like these different configurations that we were talking about as viable options, and that we'd later like more end up with a portfolio of like, hey, if you focus on the reality aspect of your transition, for example, use a HoloLens to kind of do this because text is readable. Do you expect something in this direction so that we have a more diverse set of prototyping technologies in a sense that we use to test these cross-reality systems? And that just in the round, so whoever wants to answer can go ahead. Okay, it seems that everyone is like thinking yes.
I'll just add that I do think that the new tools will incorporate, and maybe also new tools around pass-through. I think it's an interesting way forward. What is called pass-through right now, and I think there's a lot more that you can do. I mean, VRception claimed a little bit of space, but I think it's a very early exploration. So I think I would not discourage any PhD students working on this just because there's a VRception which claims a lot of the design space, but I think there's a lot more that can be done, and so hope you get to see more tools in that space.
Yeah,
I'll just add a thought. I think that as we see, more focus on the metaverse and creating ways for multiple devices to access these shared environments, whether it's VR, AR, or a mix there. I think we'll see more tools to answer your question. I think we will see more tools come on the market. I look back to the early internet days, and in the early internet days, there were very few prototyping tools. And then we've got so many that have come up over the last few years. And I think we will see this boom of new tools being created as people are looking for ways to create interactions across these various spectrum of devices, because I think prior to that, prior to this boom we're seeing, there was, focus on these isolated, silos, but I think it's become more consumer focused, where they're going to be wanting to create these shared interactions across these spectrum of devices. It's going to become more of a norm. And so because of that, we're going to see more interest, I think, in these prototyping tools.
Mm-hmm. Yeah, thank you very much. I would kind of, for this last part of the discussion, move it a little bit closer to the aspect that was also mentioned about security and privacy. I think that is also a very important aspect here. And we talked a lot about now prototyping, but like the systems in the end that we develop, the more we allow for this transitioning and stuff. You see, like the Oculus Quest, for example, requires additional sensors. Now there are colored cameras facing and scanning the room, so we add additional capabilities, and there's this kind of trade-off versus the technology and the user acceptance, right? So like if we put like a bunch more sensors on those devices, that's great, but it will probably not help to contribute to user acceptance in a way, right? Like who is willing to fully have camera captures of their private homes? Like maybe there are more sensors coming. So what's your take? So I think there was also somebody like putting in the card here, new cross-reality UX interaction design guidelines that also include security and privacy considerations. So maybe the person who put that in can...
I put that one, but I think at the bottom is another one that also mentions study the implications on safety, security, and privacy is like bottom center. I wonder whether who put that one. Maybe they can comment.
Maybe that was Mohammed and he just left.
Yeah, he's just like, drop this here and I'll leave you alone with it. So I personally, so when I put this down, so actually I think we need both. We need more guidelines, interaction design. As you also see a lot of consistency, like UX consistency kind of things, which is actually very interesting when you think about how you design an interface that can adapt to different modalities. What is actually still consistent? And I think the haptic component is probably the one that's going to be consistent. if you're like thinking about a full-fledged, fully like multi-model AR VR, what stays consistent is maybe the haptic component, and that's at least that's the thought. On the other hand, so I think part of what I put down was like a cry for new UI UX interaction design guidelines. We've done a review of the ones that are out there, and there's a lot of issues with current guidelines. Is actually they're like keep the user safe. Yeah, great guideline. It's like the 10 golden rules or whatever, Nielsen's heuristics. So how funny how we always recite them to each other, but they're actually not operationalizable. They're not, I mean, they're meaningful, but they're not actually really like at the precision that they're actually useful. And I think the other big thing is that they just completely lack security and privacy considerations. And they're like really, like Mohammed is back now. We have like people like Mohammed who's specialized in this. He understands threat models and all this kind of stuff. As a user experience designer, a lot of the people that I work with, they often don't have the background. We think primarily about the user and how they want to interact with the environment and whatnot. We don't think about non-users, bystanders, adversaries. And then now you want to switch modalities. And so I think, Mohammed, did you put down the one at the bottom, study implications of on safety, security, and privacy?
Yeah, exactly. So I think one of the things we need to think about, as you were saying, what are the potential things that could go wrong, and how could they affect the safety of users and also people around them? So yeah, Jan and I did some work recently on like manipulations in VR, and how someone might in VR, for example, think that they're punching a zombie, but actually, they end up punching a real person, or thinking that there's an object in the real world, and the mapping is not consistent. So they would think that there's a chair, they try to sit, and it wouldn't be there. So I think these things may even be more dangerous if we go into cross reality, because you have all these things that need to be synchronized, and yeah, basically, if there is a mismatch, there is a chance that the users might be exposed to physical harm, as well as, of course, all the sensors have privacy implications. And then the question is also in terms of security, we're still using pins and patterns and very old methods in VR and AR. So do we also keep on using those? I think, the obvious answer is no, but we need to do more work in that area to develop methods that are secure and also usable and suitable for that context.
Mm-hmm. I think the aspect that you mentioned, where you kind of like say that we are getting better at like mixing these things, right? Like syncing up the coordinate spaces of a reality experience and a virtual reality experience is something that inherently comes with cross-reality systems. So we kind of, for the persistencies of these experiences. What you kind of mentioned sounded a little bit like somebody like a hacker, like attacking a person by kind of injecting this information. But can you imagine it as to everyone, kind of, can you imagine that when we like sync these spaces and we replace real world objects, for example, with some virtual component? So you made the example of the zombie, that maybe replaces like a bystander in a way. Do you see like a risk of us losing a little bit track of reality in a sense, and kind of interacting with the virtual appearance that we perceive rather than the physical one that is actually there? Like, is there?
That's a deep question. So about like how people will lose touch with reality and so on. I think I don't have enough I'm not really acquainted with the literature in that domain, but what I can tell you about what you mentioned earlier, because you mentioned like a threat where a hacker could do something like that, but actually we always think of a scenario where, or I think it's easiest to think of a scenario where there is a malicious actor who hacks into a device or does something to target this particular person. But then there's also the possibility of people building equivalent of malware, for example, or malicious applications that could look like I could, for example, if I could create an app that looks like Beat Saber, and people may end up installing it, but then it does something different. But then there was also the dangers where people could like basically, if you can imagine a scenario where companies may try to sabotage other companies by for example, spreading certain apps on their platforms. Like imagine if it happens on the news like once or twice that someone gets into physical danger, or into like they get hurt, for example, or they get attacked due to a problem like the ones we've been talking about. It just takes 1 or 2 articles online for a company to have very big issues. So this could be also a direction where attackers could, like channels from which these attackers could, or actually ways for this threat to happen.
Mm-hmm. I think Hassan, you had a
like I wanted to extend upon that. If you think of something like diminished reality, for example, and integrating that with augmented reality applications or any of that sort, then real world objects could be removed, replaced with something else within, like if you think of the Oculus Quest, and you can like see like your room when you're not really in a VR application. However, you can still, using diminished reality, you can still replace some objects. What actually worries me more with like using diminished reality with AR or VR applications is it's like how it will influence ads. Like I can imagine, for example, your like use your iPhone every now and then, and you're using some AR applications, or you're using the Oculus Quest, and it kind of creates this reconstruction of your room, and then it can identify using segmentation certain objects. So it knows, oh, you have this couch, or you have this chair, and it says, okay, this is approximately 30 centimeters by 50 centimeters. Okay, how about we using diminished reality, remove this chair and we place this other chair and go like, hey, this works well with your home, right? How about you buy this, or things like that. And this, of course, can be used maliciously as well. But I really feel that it's gonna bit by bit be the norm, right? If more people start using VR headsets, and I know that Meta already has like acquired a diminished reality company, so like the track record doesn't like
Mm-hmm. Yeah, so you bring up the point that it's not necessarily always like a privacy and security aspect where there's somebody like maliciously trying something, but it can also be like an accepted thing in the future, like
exactly
in marketing or something like this, where it's not really like something that we can that we think is bad, but that we cannot clearly classify as like malicious in a way there.
Exactly. Like it's also like Khamis mentioned, you similar to like posts or articles about Facebook's or Meta's like how it's tracking you through websites, and then like when you look here in Germany, for example, how people are towards social media. They're very like conservative, and they push away social media mostly because of that. And you can't actually buy an Oculus Quest in Germany legally or officially, right? You have to buy it through a different country or so, and then bring it onto Germany. So like imagine kind of how when you have like something like VR, and imagine how if it's used for ads, like the social implications for that as well. So some countries might accept it, other countries won't, but it still will be within the legal kind of framework somehow.
Mm-hmm. All right. So given the quite advanced time, I would conclude this session here. So originally we had planned to kind of go into potential research contributions and form collaborations. But I think that is a little bit too much for like the large group that we are. And since we don't have breakout sessions and no time available anymore anyways, that solves it. But I hope that this discussion sparked some interest, and you can also see that many people were active in putting like opportunities and challenges. So if you're interested in collaborating with someone, or like you have an idea where you would like to work with somebody, then please get in touch with each other. So the Mirrorbot will be available also afterwards. Yeah, we can also help you send around like contact information. So if you want to contact somebody from the workshop, thought that's interesting, we will always be happy to put you in contact. Yeah, with that, thank you very much. We have another coffee break, a last coffee break before we do the second paper session and the closing keynote. I'm looking forward to already a lot, but also the paper presentations, of course. So I would say we kind of, let me quickly glance at the schedule. Yeah, so to be back in time, because like there are also the authors maybe joining in, we continue at 20 before whatever hour your clock says at the moment, and give you like around 15 minutes of break, and then see you all back with the next session. Welcome back to the last part of the workshop for today. We are having the paper session now and the closing keynote in a moment. Let me briefly share my slides so that you get an overview of the papers that we expect in the session. So these papers will be presented in this session, and the chair of the session will be Jonas, and hereby I hand over to you, Jonas.
Okay, thank you. Thank you. Okay, we have 4 papers, and I think we can start right away with Mohammed. I think he's going to present this one. So yep. Hybrid access and immersive analytics tool with interoperability between 2D and immersive reality modes. Mohammed, are you there?
Yep. Yeah, I'm going to share my screen in a moment. Can you see my screen?
We can't see a screen right now.
Oh, okay. Sorry about that. Technical problems with my laptop. Okay, now it should work. You can see that right now.
Okay, now it works. Thank you.
All right, right. Okay, hello everyone. My name is Mohammed Rajabi Saraji. I'll go by Mo. I'm here to present hybrid access for you. So, what is hybrid access? Hybrid access is an immersive visualization, immersive data analytics tool that allows its users to create a different data visualization and then seamlessly move between 2D desktop and then 3D virtual space, immersive space. Our goal in creation of this tool was that we were having this feature in mind that people are using this sort of application to support their day-to-day routine and day-to-day basis, in which they work with a desktop and they can have not a non-intrusive AR headset that they can just put on, or AR glasses that they just can put on, and then they can do some part of their analysis in AR and then move back to desktop on demand. Now, before getting into that, I need to talk about 2 things. First of all is immersive analytics, which is just basically the using of immersive technologies to carry out visual data analysis tasks. It's been around for a while, since the 90s, but why I'm interested in it and why I think that there's interest in it is that there has been work that showing 3D visualizations in 3D spaces and 3D immersive spaces has some beneficials for the users in the fact that it can make the sense making and the data understanding easier for them. So that's one of the reasons that I'm interested in this area. 2 of the works that really heavily inspired and helped our work here, one of them is IMAXIS and the other one is Fiesta. So both of these tools, they provide some sort of tool sets, some sort of systems to enable users to quickly create different data visualizations. Both of these tools are in Viardo. One of them, Fiesta, it allows users to collaboratively create these different visualizations and work on them. The other part that I need to talk about is cross-virtuality analytics. So I know that every one of you have seen this image a lot throughout the session, but hey, here it is once again. So cross-virtuality analytics, the thing that I'm going to talk about is it refers to a data analytics system that can operate in like more than one point throughout the spectrum at once. So let's say you have a system that one part of it is in AR, the other part is in either desktop or in a real environment or in augmented or in virtual reality. That would qualify as a cross-virtuality analytics here. Now, some of the works that I'm interested in while we were going through our review phase were works that showed, okay, we can extend the capabilities of desktop using AR by just simulating other desktops in AR, like around your desktop, or we can have works that we can have systems that work on providing some authoring abilities for AR systems on top of 2D visualizations on mobile and tablet. And then some other works that show the benefits of combining 2D visualizations with static or dynamic 3D ones. One of the other works that heavily inspired this work was Immersive Insights by Marco Cavallo. What they did in this work is that they put a bunch of different data analysts in an environment just as the one that you can see in this image, with a lot of different large screens, and they gave them headsets, like AR headset and VR headsets, and they tested multiple different scenarios. Users could see different data visualizations, work with them, and then they had tasks and they had to come up with some answers to these questions and tasks. What they found out was that they found that there are probable advantages to using AR with these large screen displays to do data analysis tasks. But the thing is, they didn't provide any concrete evidence for that, and they mostly did it only in viewing visualizations, but not authoring them. The other work that came out last year, and it also did a lot in this sense, was a Grand Challenges in Immersive Analytics survey. The work that they did a lot of different things, but two of the points that I'm interested in and two of the points that were factored in heavily in our work was that they stated that there is a need for a kind of interoperable system that can operate between 2D desktops and then immersive environments like AR, VR. And this sort of transition between 2D real world or desktop to this 3D real world should exist, but this should be a meaningful transition and not be something, it should be something that makes sense to the users while they make this transition. So why create our system? We wanted to use those benefits of showing 3D visualizations in 3D space. And we saw that there's a lack of visualization systems right now in the area with good fast authoring abilities in an AR space combined with a desktop system. But in the end, what we wanted to see was that we wanted to investigate the behaviors of the users that are using these different systems. We want to see what patterns come out of it. How do the users behave while they want to create this sort of hybrid visualizations, and then to take these and compile them into guidelines to be used for creating better hybrid systems later on. So to do that, we had a bunch of design goals. So the first one is that we wanted to create the AR side of things and the desktop side of things as equal as possible in the feature set, so that when people switch to one of their systems compared to the other, it's not just because a feature doesn't exist in one compared to the other one. We also wanted to make this transition, as we said, seamless and meaningful, with clear signaling that this transition is happening, why it is happening, and this is how it's going to impact your visualization. And another fact that was really important for us was the cross-reality progress sharing. We wanted that when users move between AR to desktop, different attributes of their visualization also move with them. And when they do something in AR and desktop, they can see those changes affected in the other part of their system, in the other part of their subsystem. And we also needed a low context switching cost for all of our users, because we knew that that was a pain point. So for the subsystems, for the AR subsystem features, I'm going to show you a video and I'm just going to talk over that. But yeah, actually, let's see the video. So here you can see that this is a setup that we have. We have a kind of virtual desktop put in there with a data shelf that users can access. Users can easily grab and place different visualizations if you have seen and read IMAX's paper, this is a pretty similar environment in that sense. Users can simply grab different data dimensions, which are here in forms of histograms, create different 2D, 3D scatter plots. Now I'm gonna move this along a bit faster. Yep, they can create 2D scatter plots. They can access the details on demand. And right now we're using the video see-through image, video see-through headset, Varjo basically. And here was a synchronized brushing that I was talking about. So if you brush something, if you highlight some points in AR, you can see those points also reflected on desktop and vice versa. We also provided the ability for cloning so that when people want to make branches of their visualization, do some work on them, and then transition to desktop or transition to a new visualization, they can do so. And that is right now also in the system. Right now, you saw that when they want to create, when they want to transition something that they have on the desktop to the AR space, they can just reach out to the monitor, grab that thing, and take it outside. And the other part that was only present in the 3D environment is the creation of 3D visualizations, because making these kind of 3D visualizations did not make that much of a sense based on the reviews that we've done before on desktop. So people do not tend to create that many different visualizations, like 3D visualizations on desktop, because working with them has proven to be a hassle for them. And what you can see is that the user, one of our pilot users that we were working with, is creating 3D visualizations. They're brushing the points that they wanted to see, and they wanted to access these points later on a map that they have on desktop. So what they've done here is that they're just brushing through all of them, and then using a glance kind of behavior that we've seen in most of our users, they're going back to the desktop in any moment now here, and they will see those points also brushed here. Now they can work with the map and interact with different parts of the system. For the desktop subsystem here, we used CodeApp, a free open source tool that has a support for most of the functionalities that we have on the AR side. It also features a map and a note-taking system, text-based system. You can see this here. This is a video. I'm not gonna let it play, but I will talk about this part, that one of the main reasons that we use this was that it supported the same drag and drop features that we had here. You might ask yourself that why not use Tableau or something else that also supports this and is a little bit more familiar to the users. I would tell you, try to port Tableau, try to use Tableau API to do any of these things, or integrate it with WebSocket Relay, and you will see what I mean over here. Now, we created the system, and our evaluation plan for it is that we want to do a between subjects study in a mixed method way between 3 different groups: AR, only desktop, and hybrid. And we want to observe them and find out the interaction pattern they have. We also want to use desktop as the baseline for the performance. We want to see how this switching between AR and desktop is going to affect their performance, whether people are going to use it or not, and when is it and why is it that people use these different switches between AR and desktop. We had some pilot studies with 4 subjects in this hybrid system, and we had to use controllers because of some implementation problems, but we had to use controllers. So in the end, when people wanted to switch, they had to put down the controller and take down the mouse and keyboard. Some of the things that we found out from this is that people use the AR side, switch mostly to the AR side when they want to do an exploratory task. When they want to do something that is more detail intensive and needs precise interactions, they tend to go to desktop. And they also seem to use the 3D more in the way that we hypothesized they would do. So if they want to create 3D visualizations or do stuff around the spatial part of their data set, they will switch to the 3D space and use that. But we observed that there's a cognitive load of task switching when they want to move back and forth between AR and desktop. So based on what we did, what do we want to do from here? We want to actually run another study and evaluate the whole system with the criteria that we mentioned over here, fix a lot of immersion breaking issues that we've had because the prototype was in its infancy when we made those pilots, and then try to balance the features a little bit better between desktop and AR side. And finally, we want to explore the collaborative aspect of it, because it seems like it's a natural way that all of these systems are going to move towards. We later on have a presentation in another workshop in ISMAR, and we're going to work on that. But yeah, that's it. Thank you very much.
Okay, thank you, Mohammed. Very nice system. Looks pretty interesting. Uwe, did you notice that some... okay, cool. We had some connection issues in the background. Okay, all right. Okay, do not forget to add questions on the Miro board or here in the chat. We can put them on Miro if that's better for you. And we will have, like in the last session, the pool discussion afterwards. So now we could continue with the next talk, but this talk is recorded, so I will share my screen.
Hello, everyone.
Yeah, it works. Perfect.
Okay, perfect. Just okay.
Hello, everyone. The topic of my presentation is user-centered prototyping for single-user cross-reality virtual object transitions. The cross-reality is defined as the transition between or concurrent usage of multiple systems on the RV continuum. Our study focuses on the transition of virtual objects between different spaces along the Milgram spectrum, which is a scenario derived from the definition of cross-reality. Our goal is to gain more insight to develop guidelines that contribute to the user-centered single-user cross-reality applications that support the transition of virtual objects between commercially available visual output devices, including desktops, laptops, and extended reality head-mounted devices. Thus, user could move the virtual object to the spaces along the RV continuum that is most suitable for the working with it, which enhance the user experience with immersive technology. Devices are needed to support the seamless and effortless transition of virtual objects. For example, it is impossible to implement a seamless transition between a standard monitor and a VR head-mounted devices that does not support high-quality full-color mixed reality functionalities, since user will have to put on headset after moving virtual content to the headsets and take off the headset after moving virtual content back to the standard monitor. Optical see-through head-mounted devices are naturally suitable for transition of virtual objects between standard monitor and AR spaces, since the user will be able to see virtual content rendered on the monitor and head-mounted devices. Video pass-through head-mounted devices that support full-color HD mixed reality, such as Vario XR3 or MetaQuest Pro, not only support moving virtual objects between standard monitor and AR, but also support seamless transition of virtual objects between standard monitor and VR. When the user is working with a cross-reality prototype that supports virtual object transitions, the user will interact with devices that belong to at least two spaces along the RV continuum, or devices that is able to transit between at least two spaces. An important design decision is to choose the input modalities for triggering the CR transition. The developer could utilize the input modalities that are proven to be most suitable or most widely adapted for the devices in the start space and the end spaces of the CR transition. For example, let's say moving virtual objects from a standard monitor to AR or VR spaces. Mouse and keyboard can be used to select and drag the virtual objects, or simply press some button on the 2D UI in order to trigger the transition. Or developer could implement such a transition using hand gesture or VR controller so the user can select the virtual object from the standard monitor while wearing the head-mounted devices and pull the virtual object into another spaces along the RVC. Other input modalities such as eye gazing, voice input, touch surface, or wrist tracker also could be used to move virtual objects along the RV continuum. So what we want to discover at the current stage is how would a user prefer to move virtual objects from 2D standard monitor to 3D VR or AR spaces and back. during a cross-reality session while standing or sitting. When interacting with the system along RV continuum, the user tend to get reference from previous experience with a similar system. Thus, researchers and developers can implement interactions using the same way, as those have been proven to be efficient and preferred by user. However, single-user cross-reality virtual object transition is an unexplored interaction space. Thus, there's no established interaction that user can refer to trigger such a transition. In addition, previous studies point out that researchers and developers often do not share the same conceptual models as the user prefers. Currently, we are running the elicitation study to gain insight into how the user wants to move the virtual object from one reality to another. We implement the study in Unity. Participants will wear HoloLens 2 during the study, so the insight we discover from the study also apply to the transition between the standard monitor and the VR head-mount devices that support HD video pass-through functionality. We are eliciting users' interaction on moving primitive shapes between a standard monitor and AR spaces. There will be 20 references involved in this study, including selecting an object and moving it from standard monitor to a given position in the room, and also include like virtual objects shown in the room back to the monitor. In order to provide the affordance of input modalities, we will provide a short introduction of different types of input technologies and provide a list of devices associated with each type of input modality so the user can use them during the elicitation study. We want to find out what input modality and interaction the user wants to use without the limitation of current software, hardware, and the difficulty of implementation. We hope the knowledge and insight we gain from this study can be used as part of the guide for designing and implementing cross-reality virtual object transition prototypes. Thanks for listening.
Okay. So, did you resolve the issue with the not joining person, Uwe?
I'm still in the process. I talked to several people, but unfortunately, I'm not a host.
I think this person is on this paper, right? It would be nice to.
Yeah, definitely.
Yeah.
I talked to the workshop chairs in Zoom here on the thing, but like there's no assistance at the moment. So
it's really
need to figure out.
Okay, maybe we can have this solved when we come to the discussion. So we can continue with the next paper, and I'm not sure if I got the title right. A proposed prototyping platform for cross-reality interaction between desktops and augmented reality. Presented by Bobby or Matt.
And I think I'm not sure if you like set the right title there, but we're supposed to be next year.
I have two titles here, so basically then it should be this one.
There's a different title on the.
There's a
website.
different, yeah.
I think
what's a desktop AR prototyping framework? Is this the correct title?
There were some changes during the camera.
Okay, then there were some changes. Okay,
then the website
we changed it at some point.
The final title and also the final PDF.
Okay, I think we will get the right title in the next presentation.
Yes, I will present the right title, hopefully.
Okay, perfect.
Wait, does this work? Right, so if you can all see and hear me, then
yes,
I will start.
Okay.
So I'm Robbe, as I introduced myself before, and together with Matt, we wrote this paper called Towards a Desktop AR Prototyping Framework, Prototyping Cross-Reality Between Desktops and Augmented Reality. And Matt will also be presenting the second half of this presentation. So why did we choose to focus on the desktop and AR? So some people may think that the AR advanced displays might replace desktop computing, but we will not give any comment on that in this presentation. All we know for now is that currently desktop computing has got benefits over AR, such as higher resolution displays and familiar input devices, whereas augmented reality is already pretty useful in displaying 3D content and providing more intuitive spatial interactions such as hand interaction. So we wish to develop a framework where a single user can use both the desktop display and the AR head-mounted display at the same time, so that they can benefit from these complementary capabilities. A bit similar to the work that Mohammed has presented. So people have been exploring this before. So for example, in this work, they explored a visual analytic work where physicists could have access to such a hybrid visualization with a computer monitor and a AR visualization. And they actually found that the hybrid setup was preferred by the physicists over the only in AR visualization or only on the desktop visualization. Right, so what goes into developing an application like this is that you need two application instances. So one is running on the HoloLens or AR device, and one is running on the desktop. This provides some implementation challenges. And we wish to provide a framework that actually does a bit of the hard work and provides a seamless display space where content that supports content that transitions between AR and desktop spaces. And it also handles other aspects of the setup, such as calibration, for example. So then I'll present a little bit of related work about this. So there's this older work where cross-dimensional, gestural interactions have been investigated. So this is a method how the content transitioning could work, for example, where object is being pulled in and out of the 2D display area. And then there's also this work on the spatial cursor. So we also wish to support a mouse that moves into 3D space. So for example, here the mouse can move off the regular displays and move into the surrounding area. So that's also something we wish to support in AR. Right. So then we created a proof of concept for this. So the proof of concept is consists of two application instances of the same project, and one is running on the desktop, and that provides the on-screen visualizations, and then one is running on the HoloLens, and that provides the content, visualizes the content in the AR space, and we created this in Unity. And so the way it works is that the desktop application functions as a server, and the HoloLens application as a client. And the server synchronizes the object positions and other content updates to the client. And it also is responsible for capturing the mouse input. And then the HoloLens captures the hand inputs and then synchronizes those with the server. And then I'll show a little video of what this current proof of concept, which we'd like to expand further into an actual framework, what that looks like right now. So there's the yellow ball, which is the cursor, and it can move and pick up an object and move it off the screen into AR space. And then it also supports hand interaction. So you can pick up an object and move it into the screen. And currently it's set up that it's a kind of a task where the two orbs have to touch, and then it generates two new positions. So that's why it will disappear in a second. And so it can actually move into the screen. And the way we currently handle the seamless display space is by visualizing everything that's behind the screen will be visualized on the screen. So it's a very ad hoc way of doing it. So if you will move the ball behind the screen, then it will be shown on the screen. That's basically how it works right now. Okay. Oops, I exited. Right, and then Matt will continue with the rest of the presentation and give some more details on the framework.
Yeah, so in thinking about our conceptual framework that is hopefully broadly applicable and could guide the development of this tool. So we wanted a framework that could describe this computing space. So both describe the space and how the user might interact, might interact with the space in interesting cross-reality ways. So in terms of the inputs and the outputs, and also in some of the higher level actions that the user might want to do. So on this slide, we've got two views kind of this same, of the same frame or I guess a division of space around the user. So on the left is a top-down view, and on the right is from the user's first-person perspective, where the user is the yellow triangle in the left figure. So we divided it into the on-screen space, which is just your 2D display space, and then the space seen through the AR head-worn display is the desk surface and the reach cylinder, and that's our off-screen 3D AR space. And we chose those because we're imagining this as a single user setup where they're at a workstation, and so the things that are easily accessible to them are their desk surface, and then the things within their reach kind of in this cylinder around them. And the cylinder also makes it easy to extend the mouse as a device that can interact in the 3D space, because it can follow this curve. So we're reducing the dimensionality of the mouse to make that a little bit more simple and intuitive. So next slide. So and the input modalities we're looking at for this are just the most common inputs for each of those kinds of displays. So in AR, so we're doing tracked hands, and for the desktop, we're doing the mouse. So next. Right, so and then we'll get into the kind of cross-reality interaction cases that that we enumerated with this framework. So how these input devices might be used in these spaces. So and in the cross-reality sense, so outside of the traditional ways that use these. So first step is just using an input device outside of its traditional display space. So using the mouse in the off-screen 3D AR space, and using the hand on screen to manipulate things. So yeah, just a straightforward case. So next. Now, a little bit more cross reality is when one input device has its effects or its output in the other display space. So you can have, your on-screen input having an effect off-screen, or you can have your off-screen input having an effect on-screen. So, like, you could have a 3D gizmo on your desk surface seen through AR, and you could be using that for kind of coarse rotational manipulations, for example, of an object that you're seeing. Maybe it's a globe or an object that you're modeling on screen that you want to see in high resolution. So that's that kind of cross reality aspect there. And then extending that one more step, I guess, is when you would have the virtual object duplicated both on screen and off screen. So the same kind of thing where you're working in one particular input modality, but you can see the effects both on and off screen. So you might be doing some fine manipulations on an object on screen. You of course want to see it reflected there, but you also might want to see the object also off screen in nearby 3D space as well. And then next is using both hands at once, right? So we have two hands and two kinds of input modalities, so we could also do them, both at once. So both inputs in the same display space, or pretty interestingly, in a way that kind of opens this up to, I think much more than what we just have diagrammed on the slide, but using each input in a different display space. So you could have your mouse on screen, and you could have your hand off screen, and they could each be doing something different, or you could think of them in a more connected way. So you could be selecting an object off to the side of the screen, and using your mouse to specify a location on screen to like transport the objects to, which is our first cross-reality transition, a bimanual transition where you're doing just that. You select an object and then with your hand and then click on the screen, and then it transitions across realities that way. And of course, that's just one example. You could switch those up, input, output, whatever. And then the last transition that we enumerated is the same thing, but in a batched way. Like if you have multiple objects that you're working with in either display space, you can select all of them at once, and then in a single action, you can shift them all into the other one. And that is our proposed framework. Thank you.
Okay, thank you. Looks like a really nice prototype. Don't forget to add some. Oh yeah, you have quite a lot of questions now, but we could have, yeah, just put your question on Miro. So I think we have one left, the holotype cross-reality paper, cross-reality communication training for minimal verbal autistic persons. Is Lawrence here? Hi.
Good evening, good morning, depending on where you're located in the world. My name is Lawrence. I'm a postdoc at the University of Calgary, and I'm presenting our paper about an application we called holotype. Can you just confirm that you can see my screen before I continue?
Yeah, everything looks fine.
Perfect, thank you very much. So this project is based at the mostly the University of Calgary, Department of Software Engineering, and the Department of Computer Science as well. And we also collaborate with the University of Virginia, the Department of Psychology. So who are our end users? We deal with a community of autistic people, usually, or statistically, I should say, 1/3 of autistic people are severely affected by autism, that they can't have reliable control over the vocal cords, which makes them either unreliably speakers, or they call them minimally verbal people. Either way, some people end up using typing software on iPad or keyboards to communicate, and there's another group of people in this community who use what you see here. We call it letterboard. And there's literally just a paper that has the alphabet. They refer at these, or they point at these letters to communicate. And even this skill sometimes takes up to 2 or 3 years to get there, where there is enough muscle coordination to point at these letters. To do so, this community deploy what's called Trusted Communication and Regulation Partner, CRP. Only a few countries in the world provide such training, and having access to one of these CRPs is really difficult, and sometimes it's not even possible. So if you don't have access to these CRPs, and you don't have access to this kind of training, and you're an autistic person who can't speak, chances are very high you're not going to be able to communicate to anyone, period. There's another benefit of having the CRP, this person next to them. They help with the attentional and the emotional regulation. They call these co-regulation. So what we thought we could do is to move from, or this is at least the end goal of the project, is to move from these physical boards to holographic typing, where people could actually use head-mounted devices to type, and then naturally these software could read aloud what these people are typing. So we understand that this goal is a little bit far. It's going to take some time for us to get there. Technology challenging and the training that it takes to switch. So in the meantime, we wanted to introduce tailored training applications based on the user's motor skills. And that means we introduced different ways of having these letterboards and the tools that gets for the student to eventually use even a segment of these letterboards. So here, because we understand also having this person next to them during the training and during the transitioning is very important. And so we see great potential for utilizing cross reality, where we want to bring both the user and their CRP, or if you want to call them teacher, sure. We want to bring them both into the physical and the virtual world together to learn. So this is where we start to think more into bringing cross reality and what does that look like. So what we've done so far, we created a web application. We called it Lesson Loader, and this allows those teachers to create tailored lessons for the individual, because as we all know, autism is a spectrum. It's very hard to find two people who have exactly same motor skills, same interests, same everything. Based on that, we have to always think about customization. Everything has to be as customized as possible. So we started with the lessons. What are these lessons and the lessons we use throughout the training? The second part we worked on, we created this holotype application, and then quickly we realized the users can't be alone in this virtual world, as I mentioned before. So we ended up with two user modes, the student mode and the CRP mode. So let's look at these, how they look like. The lesson loader is basically a web application. This is a screenshot of it. It's published already. And this is for the CRP. They can start designing a lesson. They choose the level or the difficulty here, and then they can choose the type of interaction. This is an example of the teacher who wants to use multiple choices questions just to practice pushing buttons. So interesting questions. And once they're done, they can hit the either add other interactions or hit the finish button. And this is basically, it's just going to wrap everything in one simple JSON file, send it over a RESTful APIs to the holotype application on the HoloLens. Now the holotype from the CRP mode, it allows the CRP to start the application and create a session for the student to join, and then choose the lesson. So we have here the 3 motor skills: beginner, intermediate, and advanced, and the difficulty within each of these. And then maybe we took this screenshot too early, but this should show here the lessons available. And then really the most important aspect of it is just to observe and assist the student. Observing allow us to look at the student's pattern, where their hand is going, where they're struggling, and assist. I will talk about it very quickly and very soon too. So here, this is how the holotype looks like from the student mode. We see a question, very simple question, and it has 2 buttons. What you see here is the student and then the CRP holding their hand. They call this technique, and this is essential technique throughout the practice, called hand over hand. And what does it mean? If the person does not have the neural path to go and push that button yet, they don't have the muscle skills to go and push that particular button, the CRP here holds their hand, and they literally do it like up to 10 or 15 times until now their brain knows that I could actually push this button. And then they do the same thing for the second button until now they can actually choose this or that, and then we can change the questions. So now they are able to at least push 2 buttons, and then we start increasing it this way. And this is just adapted from what they do in the training on those physical boards too. They start with only 2 letters, and then they start increasing all the way to a 4 letter. So this is a screenshot from the intermediate mode, where students After they practice, they go into the 5 segments keyboard, push a button, and then it shows you the letters from A to H, and then to H, and then they can move. And the goal is, at some point, we completely switch to holographic buttons to simulate this whole experience. So this is just a very quick demo of what it looks like in the lab now.
Who invented the bicycle? The answer is a little more complicated than you may think. A German baron named Karl von Drais made the first major development when he created a steerable, two-wheeled contraption in 1817. If the bicycle was invented in 1817 and the year is 2021, how many years do you think have passed? 104 or 204?
So what we try to do here is the user interface for the student will always be facing them, because again, sometimes due to emotional regulation or even just not having full control over the body muscles, our participant could be subjected to just involuntarily movement, whether it's hand flapping or head moving or even chair rocking. This way, the user interface has to always be following the person. And so the teacher has to always be seeing it as it follows the student. So we've been running user studies not without the cross reality yet in 3 different cities in the US and in Canada. So far, the results are positive, and now we want to bring into this integration to the project. And then we're thinking a little bit ahead, like beside just observing and having this hand over hand, what else can we benefit from the cross reality integration? I have this quick sketch here to demonstrate other venues. So here, if we have a student who's practicing how to spell the word home, and then they are being, at the same time, they're being watched and observed by their teacher who's sitting next to them. Here, we started to see there are actually more benefits to having giving the teacher some sort of control over the user interface, because they can move now the user interface forward, backward, left, right, up and down. And this is very, very important, because we notice we have some users who have very good precision if their hand is very close and they're moving only this part of their arm. Whereas if the user interface slightly further, once they have to reach this way, they don't have that much coordination. So now the teacher can actually tailor even the user interface for the user. They can also help sometimes, like adding buttons that can show those hand coach or repeat the question, give different types of cues, or even skip the question, going to the back question, and have some other functions to control the lesson itself. So these are the new integrations we'll be adding to what we have, and then we plan to run the study hopefully in starting in mid-November once we add all these. So now, what about remote integrations? Because as I mentioned, having the access to the CRP is not really easy. So we're thinking about in the future, maybe facilitate group lessons, maybe 2 or 3 students and a teacher in the same place. And this is really important for this community. They've never actually experienced those classroom environment. We also thinking about during the transitioning, perhaps have some sort of temporary interventions via handheld devices like an iPad, where the teacher is holding an iPad, just watching them, and then give them that sense of, okay, can you try it now alone? And also we're thinking about remote lessons via VR. Perhaps the CRP can join a session with a student using VR, and that would be really big benefit of cross reality in this sense, and also create some sort of remote group lessons. I believe that's all we have for today. Thank you very much.
Okay, thank you. Very interesting research, or an agenda of research. So we can go over to the discussion phase. And I see some questions were already answered on Miro. So I put some there, but I would give, if somebody wants to start from the attendees, but I can start also. So for the visualization paper, the hybrid access, I was interested in what kind of data is suitable for the visualization and which is not. Are there differences in the approaches presented for different kinds of data? For example, I don't know, continuous data, or for example, data from scientific visualization which relies heavily on 3D, or from InfoWiz, which is mostly 2D?
Yeah, that is a very good point. So right now, the data sets that we're going with are just multivariate data sets that are mostly have data with spatial aspects about it. One thing that we figured out was that if you don't have a data that makes sense to be in 3D, people still make a lot of 3D visualizations, but then they will have problems analyzing it. So they basically rotate that thing around until they get to a 2D view of it, or they just use it to analyze clusters of data to find out clusters of data. So it really depends. It really depends. What we've come out with is that if your data has some sort of spatial characteristics to it, it would be really better for this sort of systems.
So basically more for scientific visualization approaches. I think I saw something from physics in the third talk, right? What exactly was that?
It was one of our related works that we presented, which was also a kind of augmented desktop visualization for physicists.
And how did they use the 3D aspect of the visualization? Why was it important in this case?
Well, it's not my work, but I believe they were investigating particle positions and movements, and it's very complicated data set with lots of data. And then the third dimension, because it's inherently a 3D data set, because it visualizes positions and trajectories. So they used it as such to view the data in 3D.
So what I thought of, if you have different data types, is it important to have different transitions? So for example, if you have I don't know, 3D data that is really heavily or really registered in space, should you, I don't know, transition inside of the data to see it around you, or do you need an overview from the top or something? Maybe somebody has an answer to that.
Actually, there is a really good paper, I will send it in the chat, that explores this, that yes, these transitions should be different based on the type of data that you have, even sometimes based on the way you're transferring it back to desktop. So on what side you're transferring it into the desktop, how you're getting it back from desktop to AR, these sort of transitions, they all have a role into what we understand and how that visualization changes.
Okay, thank you. So maybe I will switch to some questions that are on Miro. So let me see. So somebody's asking, I'm wondering for paper 3, so the framework, it's an interesting idea. I'm wondering if they had problems with controlling the mouse in a 3D environment. I mean, in a dense, in a sense of a degrees of freedom for the cursor in AR. Yeah, the degrees of freedom. How did you control the mouse in the 3D environment?
Yeah, so maybe first off, when they refer to they, then I need to clarify that we didn't actually do a study, so there's not really a day yet that should have had problems with it. But the way it works now is that we use the mouse only as like a 2D input device. So it hasn't really got a third dimension. It just follows along a curved plane in space. So there's not really a depth control going on. So
do you plan something like that, or?
Well, yes and no. I'm not sure. I guess we could provide a framework that supports both, and then developers need to decide what's best. But yeah, it's
I really
kind of
like the
making.
idea. I like the idea that it's. Can you go all the way around yourself when you push the
Currently not, but in the prototype, no, but in the actual thing we propose, you should be able to, yes. So yeah, I'm a bit against the idea of making the mouse, which was designed to be a 2D input device, do something it wasn't really designed for. So I think the hand tracking does complement it in a way that you can still you still have the hand input in the entirety of 3D space. So
I think there's a nice question that could be a follow-up to this one. So have you thought about a prototype device that is like a crossbreed between a mouse and a controller?
Actually, we have something in the related work, I think, but I couldn't find it right away. Maybe Matt knows more.
Are you thinking of the Flater mouse?
Yes, that's the one, but I couldn't find it right away. I went to look for it. But...
Yeah, I remember. Yeah, because Steve told us about this paper.
Yes, we discussed this.
What kind of device is that?
It's like if I'm remembering if that's the right thing, but is like and there are a couple other examples, some more recent, but it's a mouse that you can pick up and it essentially becomes a 3D tracked input device. So if you had one of those like that, Rob and I were talking that like that would be really great for that desktop AR space. Another something we were thinking about when we were working on this is we were trying to think of like the least number of things to add to a traditional setup. We're trying to think of like if you could just put a headset and a computer and a desktop computer together, and like what do you get just with that without having to do anything else? Just a side comment.
I think we have a link in the chat. Oh, yeah. Okay. I think when we're talking about input devices, would these devices be suitable also for maybe the last presentation for this target group? Is there an opinion on that?
The last paper was the one from Lawrence, right?
Yeah.
Yes. So do you have questions for me?
Yeah, the question was, I think that
I thought if input devices would also benefit your system. So I think currently you don't have any haptic feedback or something. Would that be something that it would be helpful?
It's actually needed, not just helpful. So we've been looking into different ways. How do you actually give the user some sort of haptic feedback to know when they push the button or not? We cannot use a lot of wearables because of sensory activation. Some people can't wear a ring, or they can't wear a watch that can vibrate. So these are not options. We've been looking into maybe like a stress ball that we shove some sort of small vibrating device and this mini Arduino. So as they push, then it's something vibrates to give them the haptic feedback. Another technique, we know that some of them, they use a pin to point, not their finger. Having that a little bit of extra weight gives them more control. So I'm wondering if we could actually find a pin that has a vibration feature, or if we can make our own. That's something I'm currently looking into.
Maybe the pen in the chat.
In that area, it would be really good.
Maybe, I don't know if this pen in the chat has, I would assume that it can vibrate. But yeah, it's very interesting that this weight would help. So did I get it right that weight would be helpful for you users? I think Loren's frozen. Okay, maybe when he's back, he can answer that. I will see what we have here. I think we have a lot of comments, not actual questions.
I think then the time is also okay to continue with the closing keynote for the day. I would like to thank all speakers again. Sorry to jump in right here. But we can, of course, take the questions asynchronously for like after the event. So the Miro bot will stay in place. If you feel like asking questions, I kindly also ask the authors and keynote speakers to maybe look in there. If there will not be an answer within the next week or something, I will send an email with like the question summarized and make sure that you get your answers that you seek. All right, and with that, yeah, I would like to go over to the last part of the day that I'm like very excited about. We will have a closing keynote from Adalberto Simona. He's assistant professor, I hope I pronounce this correctly, KU Leuven, something like that in our neighboring country here in Europe. I just got a message from Facebook in the morning that, you know, like sometimes you get these, or you want to revisit this memory that you shared some time ago. And I realized that exactly 5 years ago, he was the general chair for the symposium on spatial user interaction. And I got reminded because I won an award and I saw him like as the first person to sign it. So that's a nice coincidence that exactly after 5 years that happened, he's now here giving a keynote in our workshop. He has very extensive experience. So he kind of, I think in 2010, he did his PhD in HCI in Italy, then enjoyed the UK for quite some time. I think he had a Marie Curie research fellow at the Lancaster University. He was also lecturer and senior lecturer at the University of Portsmouth. And then in October 2017 started his current position. And yeah, he will talk a bit about the prototyping platform for cross-reality systems. I think it will be a bit connected to the paper that we have seen already from his students. So I'm really looking forward to the presentation. To everyone, please feel free to write your questions in the chat or on the Miro board so we can collect them and afterwards have a nice discussion with him. And with no further ado, I hand over to you, Adalberto, and look forward to your presentation.
Yeah, thank you for the presentation. Yeah, it's been quite a while. A lot has happened since then. Okay, let's see. Can you see my slides?
Yes, we see it.
All right, so I just want to make sure that it's enabled for video. Nice for video clip. All right, so yes, thanks again for the introduction. Today I will talk to you about the use of speculative methods in conjunction with immersive technologies, both for what concerns virtual reality and, of course, cross reality. So for those who might not know me, as he said, I'm Adalberto. I'm based in Belgium, in the city of Leuven, at KU Leuven University here. And the Department of Computer Science, I lead a small team of researchers who focus on immersive technologies. We call this team ARIA, now from the acronym here, Artificial Realities and the Interactive Ambience. We have worked on a variety different topics, within the domain of immersive technologies. And we have already seen Rob. He's one of our PhD students here in our team. He is working on cross reality, and he's also presenting a paper at ISMAR in the later conference. Our other PhD students have focused on other areas within VR and AR. So going back to the theme of today's workshop, like you, I've always been interested in cross-reality interaction since a long time. Before it began coalescing around the term cross-reality, there was a time some years ago at 2016 at a workshop on everyday virtual reality, in which I also was involved as an organizer, where I presented this work. At the time it was more of a design experiment. It was inspired, as the title says, by the movie Aliens. If you have seen it, the motion tracker. In the movie, it's used to track the position of the xenomorph. But in this example, it was used in conjunction with a Kinect that tracked the position of a person to show whether there were other people in the room while you were playing an immersive game. So there was this widget that you see here on the bottom that showed as dots the position of other people that you might not be aware of. So like other examples before, we were imagining a connection between one reality and another. And as time progressed, we also began exploring this in much detail. And as the idea of cross-reality gained steam, we also explored it with a workshop 2 years ago that was co-hosted with ISS. It was suitably called Workshop on Cross-Reality Interaction. So before designing this presentation, I tried to ask mid-journey, like it's now a trend, to imagine or rather dream about cross-reality interaction. So as a prompt, I asked it to draw two persons, one immersed in augmented reality and another immersed in virtual reality, who were collaborating together. I might possibly have thrown in the prompt terms like cyberpunk or dystopia, or possibly not, but the end result is not that far from the mark. No, I think that the way the AI has imagined the cross-reality interaction highlights one of the themes that I find common across the whole spectrum of immersive technology, not just cross-reality, but one that is especially relevant for cross-reality, which is the isolation in which users are placed when they are immersed in such immersive technology. Despite being on the room, they are not aware of each other. And so this is one of the themes that we began to explore in cross-reality. The fact that people might be immersed at different points of the spectrum, but unless an application is explicitly designed for use in cross-reality, they will not be able to interact with each other, of course. So they will only share the vicinity, or if one of the person is not an immersed user, but like an external person, there have to be other methods like display that mirror, for example, what the other person is seeing. Now, I'm sure that you've all run user studies in VR, so you've played that role of the external user that tries to interact with a person that is immersed, and so you have to use like methods, old methods, like watching what they are doing on a screen, for example. And there's still also a lot of work to take into account. People, that might be in the room, like people or other beings that can be in the room, like your pet, or other people that are not immersed, that might need to be represented into a cross-reality application. So the cross-reality in itself, I see it more as an umbrella term that includes different points in the reality continuum spectrum, as well as people outside. So we, of course, have augmented and virtual reality, but not immersed user, and that can also involve several different technologies, going from least immersive desktop to immersive headsets and in between. So to reflect on these challenges, now when I was writing a research proposal about cross reality, I summarized these into three main, very high-level challenge areas. Now, the first two attempt to extend the accumulated knowledge of intra-reality 3D interaction, that is interaction that happen wholly inside the same reality, as to oppose it from interaction that originate in one part of a reality and affect another part of a reality. And so, of course, as this multi-reality paradigm becomes unlocked, some of the previous knowledges that was relevant for intra-reality 3D interaction needs to be reinvented to work or perform suitably in cross-reality interaction. So we do have visualization interaction challenges, but as well as how to evaluate and prototype and design these applications. So to show a little bit of history of what we have been doing as to what concerns cross-reality. So we started looking at the visualization challenge that involves users immersed in cross-reality application. I find this is one of the most topical ones, the lack of awareness. Where if a person is immersed, they will have a version of a different reality, but people outside it will not have any idea of what is going on. Unless, as I introduced, there are some external displays that show what the immersed user is seeing. The problem is also present and maybe exacerbated if we are in another topical situation of cross-reality where there's one user in VR and another user in augmented reality. They each see their own reality, which might be different, wholly or in part from each other. And so we focus initially on the combination of users from virtual and augmented reality. But first of all, how likely is that situation to be actually plausible? We are all in this workshop interested about designing cross-reality application, but perhaps this situation is not rather common in the present, but in the near future, we surely expect it to become more commonplace. So we started looking at these issues, and fueled by the pandemic and the focus on remote working, we thought of situations like a job interview, for example, for like a bartender position. So the candidate would join in from virtual reality, to showcase the importance of sustainability, to reduce the reliance on travel, unnecessary travel. And so therefore the candidate might be a user of this cross-reality situation where they see a virtual recreation of their potential future workplace, whereas the interviewer might be in augmented reality, because that could provide some more glimpse into how the potential candidate fits into the real context. However, given the current limitation in augmented reality headset, we thought about what would be the best way to support those users interacting together. Because perhaps treating the AR headset as a VR headset might not have been the best way. So unfortunately, we didn't have a bar available, so we had to make do with our current lab, and we imagined this situation where there's a VR bartender that played like a script and tried to perform bartending tasks like mixing cocktails. So the focus on the study was more on the augmented reality user. They were watching the performance of the bartender to understand which visualization technique would best support the interviewer in appraising the performance of the other users. So this was a design work that explored different visualization technique, starting from the baseline of the where everything is visualized, like if the AR headset was used as a VR headset, and different variations of filtering, like proximity or interactive, and finally scaled view of the environment. In these videos, you can see like how this was displayed to the augmented reality user. So their goal was to watch the performance of the VR user and notice whether certain events were happening and so on. So these were examples of the other technique. This was we used a cylinder that dynamically showed only the regions of the VR environment in which the user was interacting. The interactive technique instead used only the interactive objects. Yeah, sorry, there's an error in the slide. Only objects that were previously marked as interactive, but lost the static content. And Dollhouse, that was a scaled down version of the environment, so that the user could have a view inside the environment in which everything happened. So we did a study, and we found, to keep things short, some insight into which techniques were more preferred or least preferred, and we used this feedback to revise into newer version of these techniques. So if you are interested into knowing more, I will refer you to the paper that was published last year at the IS. There's also a paper that is going to be presented at a later conference. I showed just you a glimpse. This explores the other challenge that I mentioned at the beginning, the one about interacting in cross reality. This instead focuses on the scenario in which there is, for example, like a museum curator that wants to design an augmented tour guide in the physical world, but uses a virtual version of the which shows the artifact in its historical context. And so they have the task of transitioning objects from one reality to another. So I surely recommend you watch Rob's presentation later this week. But here, so now to go to the actual theme of this presentation. So one of the issues that we have been studying is what to do when the technological constraints of current augmented reality and mixed reality headset are limiting. No? So what do we do when we would like to explore challenges that we are confident users in the near future will face? So what solutions have there been explored? So the use of speculative methods in HCI is not new, of course. In recent years, we have seen an increased attention over these methods that look at possible or alternate future. For example, in 2015, there was this paper by Lindley and Colton that was called A Game of Drones that explored this idea of a design fiction. So it was a paper that showed the use of citizen-enforced use of drones that were used by citizens to help authorities find cars that should be fined. But and so the paper presented a regular study, with results, but only in the conclusion it was revealed that it was a fictional study. It never happened, and it was used as a way to reflect on the idea and to explore these design potential. User enactments instead by Odo et al. Go a step further, and not only they create a tangible rendition of an imagined technology, but they also attempt to recreate the social context in which the technology can be used. So they use what technology available today to approximate an idealized version of an artifact that they want to inquire about. And lately, there's also been this paper by Elsden et al. On speculative enactments, where they explore the use of actors, for example, that engage participants to speculate about potential futures with the help of materials such as props or conversational starters. But in this way, the actors themselves and the participant are co-creator of the experience. However, the main limitation of these technologies, of these speculative methods, is that there are limits to what is possible to achieve through imagination alone or by building tangible props in the real world. And here is where VR comes in, I think. Immersive technologies such as virtual reality can help us making these possible future more real and more believable. In VR, we are, of course, not bound by technological limitations. The future that we imagine can be depicted in its truest form. not only can we define all aspects of a speculative technology, but we could also create the context in which said technology will be used and have complete control over it. And indeed, we have not been the only ones that have explored the use of VR to enact scenarios that are maybe not feasible in the real world right now. For example, immersive design fiction extend the concept of the science fiction to VR, where users explore this story world about potential experiences. Then there have also been virtual field studies where the use of VR helps simulate real world situations that are difficult to replicate, such as the presence of virtual crowds, for example, to help in this kind of field studies. There are also, hypothetical VR experiences, such as nuclear biscuit, and probably is a bit relevant right now. This experience explores how we would respond if we were the president of the United States and needed to decide how to retaliate to an incoming Russian nuclear attack. And so, yes, so the experience asked, what would our response be? And surprisingly, no response was not a potential response. So you had to choose what to target and so on. And now that comes the question. So what if we used VR to simulate the augmented reality of the future? And indeed, this idea is, of course, not completely new. And last year, in 2021, at IEEE VR, this was this interesting paper by Grandi et al., which explored similar themes. So how to simulate a future or AR interface. In the example taken from their video, it was, you can see probably here in the bottom part, I think it was a wrist-worn AR interface that was intended to be used by a policeman or a policewoman to help when stopping a car, for example, that you can see in the rest of it. So we have explored this concept of immersive speculative enactments. What does it? How does it differentiate itself from other such speculative methods? Well, we as authors of this work, we think that ISEs, for short, they don't define a strict process. No, we rather hope that it will be the community to affect how they evolve as a method. So here we propose our vision for them and how maybe the community can participate in this. So first of all, the core idea behind these speculative enactments is to leverage the immersiveness of VR to live rather than imagine a possible future. We think that if we can make the experience as believable as possible, then we could use these speculative enactments, immersive, to gather actual insights that can inform today the science of the technology of the near future. And importantly, we do not imagine such immersive enactments as the simulation of a future interface, but the simulation or approximation of the world in which said interface exists. So I think the difference is not entirely philosophical or conceptual. So we want to stress this fact is in that we want to approximate the context in which the user finds themselves together with the interface. So to achieve these goals, we created some examples of such speculative enactments where we explore this idea that we feel is one of the core concepts behind the speculative enactments, such the one that the participants users should be free to interact with everything they see and not be railroaded towards a predetermined set of interaction, because we feel that in this way we can observe the rise of emergent interaction and see, because if we take a step back and we don't not only implement the interaction that we expect people will use, we can see how the unintended usage of such technology can be used by the people who will be actually using them in the short term. And also, thirdly, we see these speculative experiences as a sandbox type of experiences, which should allow participants to see the consequences of their their actions. Where in conventional enactments, imagination can overcome these aspects. In VR, everything must be planned for. For these reasons, in the creation of our speculative enactments, we explicitly accounted for failed states or situations where users did not engage with the speculation, because we thought it also would provide some interesting insights into how the technology or the artifact that was subject of the enactment was used. And so we imagined, we developed, we designed several of these experiences, one of which was about the use of a scenario of a cross-reality lecture. In the near future, we imagined mixed reality headset could be used effectively to help instructors lecture in front of a blended audience. That is one where both physical and remote people could be present in the same room. So you can see here the user has to simulate, for example, the act of wearing this future device, and then they were placed into the actual context in which this experience will take place. So the speculative enactment had attempted to answer a question of how to represent the remote audience. Now you can see in this short video there were different ways of representing the remote audience, the students that logged in from their homes, for example, together with the students who were physically in place. So the one on the left are intended to be an abstract version of their avatars, whereas the persons on the right are supposed to be the actual physical people. The avatars were not just static, but follow the participant who played the presenter role with their gaze, for example. And the other two conditions showed other different approaches to their rendering. So in the top right, you had stylized version of the avatars that approximated the photorealistic ones, but had more cartoonish overtones. And the abstract, you saw them previously. And on the bottom was the fourth variation, which represented a baseline condition that, as you can see, approximated an all too familiar video conferencing call user interface. And in this experience, participants were asked to explain the meaning of a set of charts to the audience. They were playing the role of a university lecturer, but of course, we couldn't ask them to prepare a full lecture. So we gave them some charts that showed data, and they had to explain it to the audience. And so we performed a study where we immersed participants into such an experience, because importantly, we couldn't do the same as we imagined using today's technologies. And importantly, the speculative enactment allowed us to inform on a potential design choice, which was, for example, which rendering style could be better used in such a scenario. So the hope is that when this near future comes, we can use the knowledge that we have already gathered to inform not the design decisions of the near future in the short term. Besides this, we also had other scenarios that I will go over quickly. So we use an approach where we started from the least deviation from our current knowledge, our current technological knowledge, and to the most deviation. So this cross-reality example was set in the middle, but we had one where participants played the role of a virtual parent, because if you want to understand how life would be as a parent, it's not easy to conjure up a child or to make them participate in a user study. So a state machine that played the role of a baby would have been the best approximation. And so the participant had to be immersed into an apartment, perform some chores, while taking care for the baby that had a tendency to endanger themselves, like playing with sisters, and so on. And yeah, there are more details, but you can look up the paper if you want. And the other was about another design type of study where we wanted to understand what would be the best form factor for a hypothetical device that would allow people to understand the needs of their pets, whether it would have been better as a collar device, or a worn device, or a wrist device. And likewise, they were immersed in the apartment, and they had to take care of their dog. Yes, this was all done with Unreal, not to come back to the topic we were discussing before. And indeed, also in this case, the speculative enactment allowed us to gather some data. For example, we didn't anticipate that if the device was worn on the collar, that would not be in view for the user, so the user wouldn't see what their dog was feeling. No? Whereas when it was worn on the wrist, this was much easier to understand. And then finally, we had a fourth speculative scenario that explored the idea of the time delay communication. Now, if we take a positive stance on humanity's progress, that probably at some point in the future we will have people at least exploring other bodies in the solar system, so they will have to face the inevitability of the time delay communication. You know that if you have seen the movies, The Martian, for example, you have to wait at least 10 minutes in order to get a reply back. So at some point, the HCI designers of the future will have to maybe design the situations. And so we placed participants on the scenario that, of course, had the highest deviation from our technological perspective. If you're interested in finding out more, there's the paper that was published at CHI 2022 this year. But you know, I will talk about what the implications are for the use, you know, of these methods in HCI and in cross reality. So crucially, I think, you know, it's important to remark again that the idea that the speculative enactment simulates the scenario, not the specific interaction. So in how we have imagined them, here the user is a person in a room, so to speak. They are not a user interacting with a specific interaction technique or user interface where only that kind of interaction is supported. So there is no, in fact, we explicitly foreseen the eventuality that people might not want to engage at all with the scenario. So that still would have been a valid behavior we felt. No? So it's important that the immersive enactments explicitly foresee the potential of non-engagement. And in order to support this, it's also important to support physical interaction rather than interaction techniques. Now, this might be a very complex barrier, that we can only hope to approximate right now. Because what I mean is that I think it should be a stronger emphasis in simulating like a user interacting naturally in a virtual or cross reality environment. That means using devices with their hands instead of controllers. Unfortunately, the technology is not there yet to support this kind of natural interaction as easily, as we can in the real world. But in this regard, I will say that progress in making VR cross reality experience more believable equals to progress into how close the results that we could get from such a speculative enactment are to their equivalent version in the real world. Indeed, this brings us to the theme of the ecological validity of results that are collected from such immersive studies. So the expectation is that we can use immersive enactments to gather transferable insights for the real world. But however, one characteristic of the scenario that we have that I have presented is that they would all be extremely hard or outright impossible to run in the real world, either because technology is not quite there yet, maybe it will be there yet. It will be there with us soon. In the case of hopefully, with mixed reality headset, or in other situations, it was impossible to approximate it, as I was discussing. So when real-world validations are impossible, then we need to take the face validity of the study as the best proxy for their eventual transferability to the real world. So in the domain of cross reality, this translates to the use of methods that we routinely use in the evaluation of such experience, like presence or other behavioral measure, to understand whether participants are behaving in a manner that is adherent to what we reasonably expect them to do if the scenario were real. But this also opens up the possibility of not only replication studies, but also confirmation studies, right? To see whether we got it right, when the technology wasn't there yet, and to compare the insights that we gathered earlier in the near future when that technology becomes available. So imagining that 5 years from now, the mixed reality headset that we will have then will be much more advanced than those we have today. It will be important, I think, to see whether these speculative enactments helped us in shaping the design of future applications. And in so doing, we can improve both methods and the accuracy of the insights that we get into these enactments. Of course, there are also some various limitations, one of which is the potential ethical implications, because here, by creating a version of the future, we carry our own biases into the simulation. We are simulating our vision for the future, and we present it as a fait accompli to the user. And perhaps this also needs to be discussed, but not by the research community and by the users that are involved, into how, into not only whether these technologies work or how can we improve them, but of course whether it's these technologies or these situations or scenarios are useful for the eventual user to be enacted into the real world. And it's, yes, of course, this I mentioned at the beginning, the fact that we are interacting with VR interfaces, and that by improving that, the gap between the insight that we get into a speculative enactment will narrow when these will improve. And importantly also is to define the possible future, not as the object of the situation. Maybe some of you are familiar with this paper by Salovara et al. That explicitly discussed this idea of the deviation from our current knowledge. And so they discussed this idea of possible futures and how much they deviate from our knowledge. And I will say that the example of the cross-reality lecture can be maybe situated in these types of potential futures, where we know that it's a technical improvement that needs to happen. We don't know yet whether, like, how soon this will happen, or whether it will happen at all. But we might be confident in saying, okay, that augmented reality headset will improve these characteristics, in the future. So we can be confident at some point that it might happen in some form that approximates what our vision was. Whereas the Mars scenario, for example, it takes a lot for granted and probably will not happen in the same way that we have imagined. But it's important to perform this kind of reflection because it helps to frame, to build a frame of rules, in which to set the speculation. For example, to design the Mars scenarios, we imagined a future in the initial stage of human colonization. So that helped us in define some boundaries of what could have been plausible and what not. So it was not set like in the far future with faster than light travel. We imagined that there could have been no interplanetary internet, because that would be built. It's an actual topic of research if you're interested in that. And also, if the future is too distant, it's important to understand that we will be speculating about everything that surrounds it. So not just the artifact that is the object of the speculation, but also about furniture, decorations, social norms, cultural things that we cannot anticipate. That could also play a role and affect the potential validity of the scenario. Maybe you have seen pictures like this, how people imagined, the year 2000 in the past, and in some cases we can now say, okay, they got it very wrong. For example, this was supposed to be a postman, but in some cases they got it about right, but not close enough, as you can see here. Okay, now to conclude, I just wanted to introduce another topic that emerged during these experimentation. That is the idea of when we were running these experiments. Now, we were often in the situation where there were a person immersed in the scenario and a person outside it. So we started discussing this idea of cross-reality presence, and whether this also applies across reality. Can users feel present with other users across reality? If not, what can we use to investigate this concept? And so this we started working on this idea of supporting actual people when, for example, they are in this scenario. So to have a more immersive overview of what's going on in the experiment. So there's one person that sees inside the virtual environment, and as well as with an overview of what the immersed user is seeing into the virtual world. So, but this is still a very high work in progress. So perhaps you will see more of this in the future. All right. Well, I hope you found this half an hour or more probably interesting. So that was it for now. So if you have other questions, I'd be happy to discuss them. Yeah, thank you for listening so far.
Yeah, thank you so much. Thank you very much. Super interesting keynote. Are there any questions from the audience? Otherwise, I would take the opportunity and go and ask the first question. So I really like your speculative approach to prototyping, because it kind of allows us to step a little bit more into the future than everything else that we currently have as tools. I wonder what the role that technology plays here is. So of course, the actual hardware is influencing us in several ways, right? Like how we think about solutions, and also what we can achieve. And also when we use, for example, VR, then it comes with certain technologies. So the question is, can we really detach from the technology that is currently there? And is this useful? Is this something that we should do? Should we think about something beyond the technology that we have, or does it make more sense to kind of include this technology in a way in our speculation? So maybe you can say a few more words about this kind of relationship between the technology that's currently there and your speculative design.
Yes, no, that's an excellent question, and I try to approach that in the into the presentation. Of course, to create and design these scenarios, so it takes a lot of effort from the design and implementation perspective, because not only we have to design what is the artifact that we want to investigate into the enactment, but also everything that is happening outside of it, in the environment. So this requires first of all an effort in terms of time that is invested into creating this image. It's just almost like creating a small game-like experience. You have to design everything that encompasses it. And also the ability to interact. I stress that I think I feel it's important to be able to interact naturally in such environment. That is not something that is easily done, because the technology is not perfect in terms of simulating hand tracking and that kind of natural interaction. I think it can help if we can, build on what, like as a progressive incremental type of development. If we have interactive environments that we have built, then we can continue building on it to, in order to not start from scratch every time. And in this, I think that like environments that have available that we don't need to create ourselves can be helpful into providing these kind of interactive and supporting elements that are necessary for the experience, like interactive houses or objects, that we can put place there in case people want to interact with them. But the hope is certainly that as hand tracking recognition improves, embedded hand tracking, we can use that to introduce more and more physical type of interaction, rather than instead of grabbing an object, we are grabbing an object because of the physical constraints that are there. And I'm confident, but we will hope to see that and confirm that in the future, that this potential, this open-ended sandbox type of environment would be more rewarding in the types of insight and observation that can be gathered from that.
Mm-hmm. Yeah, thank you very much. I think there was a question from Jan, so I would kind of ask him to directly ask the question.
Yes, so thanks, Adalberto, for this really cool talk. And I asked Mark initially a really general question at the start of the workshop. I asked him what's his definition of cross reality is. And here's a little similar general question. So every time we talk about cross reality, there are aspects that you showed, like there are issues that you, like when you're in VR, you need to see the environment, right? There are problems around this coexistence into realities, and cross reality feels a little bit like a challenge. But then on the other hand, we show often really cool application scenarios for cross reality being actually an enabler for new opportunities. So what's the perspective? Is cross reality a challenge in XR that we need to solve, or is cross reality an opportunity or creates opportunities for specific unique applications or scenarios that we have? Like, how should we treat it? Is it something we need to overcome, or is it an enabler of something really new and cool?
Well, there is certainly the perspective, that as technology improves, the distinction will certainly become less relevant. We all have heard of the future headsets that will be able to seamlessly change between augmented and the virtual reality. So at some point, perhaps it will not be seen as as distinct environment as they are now. I see it now as an opportunity to explore new interaction paradigms into situations that are becoming more commonplace right now, and I don't see them necessarily being multi-user experiences. Indeed, in some of our work, we investigate them as even single user experience, where a user moves themselves from different environments. So I see as interaction originating from one environment but affecting another.
Thanks.
Yeah, you just to connect to this, I think you showed like a few examples where you were, so like now you were saying, okay, there might be, or there will be technology in the future that allows us to like seamlessly transition between like different manifestations or degrees of virtuality. But in your like papers that you showed, I thought it was quite interesting that you thought it from the object perspective, right? Like normally we kind of think of it as the user transitions from virtual to augmented reality, but there you kind of showed some ideas also how we can think of the objects itself transitioning between like different realities. So is it maybe like the wrong approach that we have thought about it too general before, kind of like as the user transitioning, but instead it makes more sense to kind of have the objects transition through the different manifestations?
Yeah, well, I don't know if there's a correct way to imagine it, but I think it certainly applies to both situations. So the user can move themselves to one reality or another, as well as the object that can be created, for example, in one reality, but they are more relevant to use into another side of reality. I mean, this opens up a lots of different perspective and challenges such that have been mentioned here in the workshop, like privacy or awareness or the feedback of acts happening in one reality, but they might have needed to be seen in other realities. And each of them, I think, requires a cross-reality approach to be able to be not say solved, but supported, for the user that engage in such experiences.
Mm-hmm. Thank you very much. Is there are there more questions? Okay, then maybe a final concluding question, even though it's mostly me now asking questions. But so in the beginning, you mentioned that this conflict, and you also talked about this in your answers now, that there's this ongoing conflict between immersive technologies and their surrounding. You even went a little bit farther by including animals and other objects that there as well. So currently, I feel like we don't see a huge user acceptance, especially in public places, for example. I never really came across somebody having their VR headset on the airplane or something like this. So do you think that with cross-reality systems and this allowing to transition and bring in objects from reality as well, that we will see higher user acceptance and also that we will see those immersive technologies be more present in public spaces or places where we don't see them at the moment?
Yeah. That is an interesting topic for discussion. And I feel that if one type of headset has gained surely more widespread type of diffusion for VR headset, it was thanks to the price point. Like a Quest is as cheap as a mobile phone nowadays, but the same cannot be said for an augmented reality headset. It costs 1,500 euros, I think. So I think we need to see a similar type of decrease in terms of price before we can expect an increase in the ubiquitousness of such device. And further along this point, it's also a matter of friction, I think, because nowadays, if we want to use our mobile phone for an augmented reality experience, even the low-tech kind that it is, we just need to to turn on our phone it's in our pocket and press a button and here it comes. Whereas an immersive experience requires more advanced planning. We have to make sure that the battery is charged, that the controllers are likewise charged, that we have the correct cable, that they are part of the same Wi-Fi network, and so on. So it's not like a plug and play, as it was said in the old days, kind of experience. And we have to plan that in advance. And there's also the problems in keeping these kind of the headsets on your head for a long time. It can be tiring because of the weight or the heat they generate. So I think that before we see acceptance, widespread acceptance, there have to be technical issues have to be mitigated at least before they move from the enthusiast kind of users to the more person on the street kind of user before we see them out in the open. At least that's my personal perspective.
Yeah, thank you very much for your insights. Another round of applause, virtual applause for our keynote speaker. Thank you very much. I think with that we reached already. Sorry. Yep.
Thank you for inviting me.
Of course. So we are at the end of the workshop. So officially it ended 2 minutes ago. So the last thing that we had written down as we wanted to do was a short wrap up of the workshop, but I will keep it rather short. So I think we had a very, very great workshop with 2 very inspiring keynotes. We had 7 paper presentations today, a very active collection and brainstorming of ideas. So if you're interested or working in the area, you can take the MiroBot as a reference. There's a nice collection now of opportunities and challenges that we need to tackle. So whenever you kind of think of a new research project that you want to do, but you lack an idea of what to do next, then just grab an idea and solve it, I guess. No, but like I would like to stay in touch with everyone. So please reach out if you have like any more questions or comments. We'll try to keep the Mirobot active. As I said before, if you post some questions, I will make sure that the authors get them. And I would really love to see everyone around, maybe also physical at a conference. That would be very nice. And with that, I thank you all for joining and making this a wonderful workshop, and have a lovely evening, day, night, whatever it is for you. Bye-bye, everyone.
Thanks. Bye.
Bye.
Jo, dann beende ich mal das Recording.